Well, good morning or afternoon, evening, wherever you might be, and welcome to another live streamed dive, or dive stream as we've been labeling them now, live from the remotely operated vehicle Sebastian, being controlled by research vessel Falcor 2. For today's dive, we are returning down to the Tica vent area on the East Pacific Rise. And we're currently just over 2.5 kilometers below the surface of the ocean. At the end of yesterday's dive, we had kind of ventured over to an area north of here called Teddy Bear. And while it had very cool terrain, it wasn't really showing good signs for the deployment of Experiment 3, which is what we are doing today with today's dive. So we've returned back down to the Tica vent area to hopefully locate a good site for experiment number 3. So that's what we're going to be doing primarily today. We've got a couple other items to attend to as well. In front of us, we have largely what we've been seeing around here as far as organisms go. We have our large Riftia tube worms, kind of look like a lipstick. The red that sticks out the end of the tube there is a gill-like structure, or a gill structure, I suppose. We also have some eel pout fish that are tucked in amongst those worms there. But currently we're just kind of scoping around for some sites to set down at. So as folks continue to trickle in at the start of our dive here, again, welcome. We are back at the Tica vent area. Just a real cool shot here showing those large Riftia tube worms, but also the smaller white Pompeii worms there. And some active smoking from this hydrothermal vent. So this area is a venting area, hydrothermally active. And of course the experiment that we're looking to place, experiment number 3, deals not only with that venting, but also the organisms found at the venting sites. And how do those organisms get there? How do they get from one venting site and then the same organisms colonize the next venting site to appear? And one idea is perhaps they are traveling through the venting fluids underneath the ground, because those venting fluids do get pulled in at little intakes into the system. They get heated and then expelled at new vent sites. And so if the organisms that are found at these vents happen to get pulled in as a larvae, or even gametes through those intakes, and they make it to the next site and are expelled at that venting water, is that a potential way that they're being spread? So the experiments are sort of monitoring these vent areas and looking to see if we see any fauna coming out. Another organism that we've seen a lot of here, in addition to the worms and the eel pouts, are the squat lobsters, which we got a couple of hopping around in front of us right now.
It's like a kitchen equipment, you can square it really smooth, it's not so important. No? The Marxist deployment, the dredging, maybe
yeah.
here, like the front basically here, and ours we put it here, so they will be pretty close together for the video.
Maybe I'm confused. This is the first thing we're doing, right?
Get some close-ups too.
That's a very
So on the this side there, we do have a little art installation on Sebastian today, and we're going to be setting this down at some point. But this is by our artist currently on board, Max Hooper Schneider.
even if it kind of tips onto
The
that.
thing is that the other one we could put maybe here if you can reach it. You know?
Control room.
It looks so better. It looks actually good. But you need to be able also to open fully to reach firebox 1, 2 and 2 already.
Right, yeah, exactly. Right now, I'm just.
So the scientists and pilots are currently getting our bearings right now. Over in the science, of course, we have Professor Monica Bright again today. If you tuned in for yesterday's dive, right, we were deploying experiment number 2 again. So some sitting still yesterday, and then we kind of scooted around. Today's going to be a little more scooting, and then hopefully we find a good site for experiment number 3, and tomorrow will be the deployment of the 3rd and final mesh box experiment.
Yeah, is that a 4
It's gonna be easier to set it with the port almost for sure.
We'll try
Pretty
that.
sure I can actually push that a little more.
Okay.
And that'll help you for the port on.
It's exciting.
Pilot's figuring out how to deploy our little art installation here. It's got a nice platform where we can grab that by.
Marks 1, marks R1, marks deployment 1.
Grab it from this side.
Yeah, if you can, grab it from the outside 90 degrees.
Just rotate it out. And don't mind, I mean, tell me if I'm doing it that way.
As long as you don't bump the chair while running the arm.
I mean, that, in theory, that's the back side of it.
Yeah, but we can always hand it off and spin it and whatnot.
Yeah.
So we do have Max Hooper Schneider in mission control right now watching this, and he's pretty excited about it all.
I might just hand it off. Yeah.
Kind of specializes in reuse, forming these little ecosystems out of human material, but kind of emulating the natural world. So for today's dive, we're just going to kind of place this here next to this venting area. This interesting ecosystem of plastic being sort of reclaimed by what's been hypothesized to be one of the forges of life, these hydrothermal vents. Just a fun scene to start our dive off with.
Did you want to take the port out? Or do you want me to get it faster? Yeah.
So we're going to spin this around here, which is going to involve some handing off between the manipulators.
From the front, right back.
This is going to be recovered at the end of today's dive, so we're just going to kind of let it sit here for the dive, and then it'll be coming back up. We also have some experiments on board from some students, so those are going to get deployed here as well, and those will be left a little while as well. I believe it's mostly different types of food that some students have a curiosity as to what their the reaction of local fauna will be to them, I believe, or the what visiting a vent site would mean to that food.
Yeah, that's in the front.
That's Frank Bradstreet, that's right.
It's for sure not flat.
Got a nice little pedestal there that we can set up. Ooh.
What happened here?
Did we still have you?
Yes, we lost one.
Got our grip loosened there a bit, so pilot's gonna work to re-grab on that.
I'll reach out just in case.
That cable's going weird. I have no policy on it.
I'm just gonna watch. I'm pretty tight. I'm about to grab it from the front.
So we'll get some, whoop. And landed upright. So we'll get that set more upright there.
Actually, I don't think it's in a really bad position.
He's gonna check his cable real quick on the back beyond. See if there's a kink or something there.
All right, we had our grip loosened, so we're currently just checking the cabling on the back of the manipulator here.
I've had multiple problems with these buttons, though. Always happens because I'm working them back and forth, so it could just be that. So we'll get it set how you want it, and then we may have to push up on that arm a little bit to get the telemetry back.
I might. Let me just grab that quick.
So we're gonna get this fully upright there down at the bottom. But again, kind of a
Actually, I don't even.
monument of the Pleistocene era, coming down here to these sort of ancient vent-like sites, you know.
Because if you pick it up, it's in the free water. You know, right now it's wedging to the muscles.
Yeah, it's good. I mean,
And I think it's,
I do have a fantasy though. I mean, tell me if I'm wrong.
yeah.
But tilting it the other way, on the other side. You think that's
On the back.
On the other side, yeah.
I mean, if we can, let's say,
On the
The
back.
two, the two pumps you mean?
take it across, yeah, 'cause, yeah,
You
ultimately,
mean like,
the only problem take it across and then tilt it into the tube worms. I mean, if that's.
So the only problem with that is, see how we're gonna grab it this
Yeah.
way?
Yeah.
Set it down.
So then we would be pitched this way, get it over here would be, we would have to spin the entire, display.
Or spin it, or set
I
it.
think we could do that, but we would need to sort out our port on first and get it up on
Yeah,
the
exactly.
Okay.
yeah, it's also. but-
Pilots are currently working to figure out how we want to best manipulate this around.
Yeah, okay, let's see if we can figure this out.
So,
And yeah, we're not leaving this down here.
Just,
This will be collected up at the end of the dive.
So usually if we move it back a little bit, it'll come back, but
So just look at
with this particular problem,
yeah. We may have to push one. Yeah, that's just changing the,
could you just double check that power is onto it?
yeah, I did. You did already? Yeah, no, yeah, the old one. Sweet. Oh, okay, hang on, I got one.
But Max actually has a background in biology and landscape, and his art kind of makes these landscapes out of well, the human sprawl.
There's that lock valve that won't let you do it much, but it did just even a little bit help the last time.
Yeah. Alright, so push on the shoulder, actually.
Obviously, you don't want to go nuclear on it, but as soon as you see movement, we'll try it. Feel like you're pushing?
Oh, yeah.
All right, coming up. Nothing. You think you might be able to get that cable a loop in the back? I'm just, I'll make sure it's loose.
Pilots are currently investigating the port side manip on ROV Sebastian.
Maybe not right at the connector, but we're
Yeah, kind of halfway through.
Yeah, exactly.
Just a little, not right at the connector, halfway down the line.
Halfway down the line.
Kind of where you're.
I'll stop, you're on the camera.
Sorry.
You're gonna have to shoulder right and pitch
Yeah.
left so you can get around the camera.
You racked it. Okay, let me try that.
There you go.
The camera with that. Yep, that worked. All right, coming up with hydraulics.
There we are.
I'm gonna get you on the other way, and we're just gonna try and use it as little as possible right now, okay?
Just a little bit of a jiggle on the arm there. It's what's interesting about something like these ROVs. The pilots are also the mechanics on all of this.
So I'm gonna shoulder left a little more here.
Having a very in-depth knowledge of the machine itself, how it should feel, how it should operate, but also how it's put together and arranged.
We gotta use it, but otherwise let's try not to, and if we do, try not to come down a lot.
All right, so now that we've got that, I think we're coming back down to the
Yeah.
sculpture. Again, we're just getting the sculpture in place. It's just going to chill here while we do the rest of the dive, and then we are going to recover that art. It'll come back up to the surface. So for this dive, just going over the other objectives, after we place this art, we've also got some student experiments to drop off, and we'll talk more about those when we do that. We'll probably check in on experimental sites 1 and 2. And those are those mesh boxes, so we'll go into those a bit as well. And then we'll also try and locate a site for experiment number 3 today, and then tomorrow will be deployment of experiment number 3, ideally. Anyone who missed right when we jumped in, we are actually back at the Tica vent area. Yesterday, towards the end of that dive, we ventured north towards a vent area known as Teddy Bear, which, while very cool, it had some really cool geology going on there. Didn't really seem to have much in the way of an ideal site for the experimental mesh boxes. So we are back in Tica vent area, kind of where we've been looking around for the other boxes already. So.
Switch on the highlight video again.
If you're just new to our dive streams in general, and you're hopping in, you're wondering, what is this? What's this weird arm? And everything else. This is actually live footage from about 2.5 kilometers below the surface of the ocean. So what looks to be a little robotic arm in front of the camera there, it actually is a robotic arm. We are looking at footage from a remotely operated vehicle named Sebastian. So think sort of like a robotic submersible. Now, there are no people in this submersible. It's actually being controlled, as the name implies, remotely from a surface vessel, the research vessel Falcor 2. And that communication actually occurs over an umbilical tether. The tether itself is 6 kilometers in length, so the ROV can go deeper than we are right now, but we're only down about 2.5 kilometers.
No kidding. I was gonna say, no, it's like a measuring device, huh? Holy moly.
Yeah, how tall is that platform?
This?
Yeah.
I want to
we
say
know?
20 inches.
About 20 inches or so, the platform?
I mean, the entire thing is, yeah, I'm pretty sure it's 20 inches.
Okay, yeah.
From top to bottom.
Okay. Oh, you got
And the platform itself is 8 inches. 8 inches.
Mm.
I would think,
Oh, yeah.
I would think if you can put the platform somewhere, wedge it somewhere, this lower part.
So yeah, if you've never tuned in for these before, we do regular dive streams. This is our 4th expedition this year so far.
This is literally just a vista for Anthem.
And so we are currently visiting the East Pacific Rise, but prior to this, we were at some seamounts off of Costa Rica, looking at nurseries of deep sea octopus in the area. And then prior to that, we were also looking at deep sea corals and also vents over in the Atlantic. After this, we're going to be moving further south. We're going to be headed towards Galapagos, and you can find out all about some of our upcoming cruises, as well as information about this ongoing cruise and the prior cruises over at schmidtocean.org. I'll actually post up the link here shortly in the chat about this current cruise. So if you want to learn more about the current cruise, we'll post that up. You can also follow along on Twitter with this cruise. If you can't, stay in for the whole dive stream, you can follow along over at Twitter with the hashtag #VentUnderworld.
You can tilt, yeah, you can tilt the fuck out of it.
So we are going to have this right here, and then we'll take a look at it. And like I said, we will be recovering this at the end of the dive. All right, so we managed to get that stand in there against this backdrop of these large Riftia tube worms.
If we're able to get, I mean, that's pretty good. This is yeah, this is a good shot.
All right, so we're just going to grab some highlight footage here of the art next to the worms, and then we'll move on with the rest of the dive. But yeah, we'll be back for this before the end. Bring it back up. So as mentioned, the artist here is Max Hooper-Schneider, who's on board for this cruise, and I have just posted up the link to the cruise page. But Max kind of specializes in repurposing, as I said, sort of artifacts of the Pleistocene era of humankind, and to have it dwarfed here in the deep sea by these monuments that the worms form is something that Max wanted to see with this sculpture. A monument in front of a monument.
I don't know if this is where's basically.
You can see that shimmering water, so that is the hydrothermal vent fluid sort of bathing this
So,
sculpture.
Close, I don't know if I'd be able to get any further.
so we could also put it then in the front. In the front.
We're now also discussing. Whoop, there it goes.
Okay.
Our sprawl falling before the vent.
Is there a way to pick it up and make it fall onto the mussels? Kind of?
He wants a muscle backdrop with it now.
That's not really coming.
We are looking at the possible deployment here of the students' experiments on board as well.
What we could do if we could deploy.
Yeah, a question of how often we stream. So we are streaming whenever we're in the water is the goal. Occasionally that gets thrown off a little bit by the weather. Of course, we are about 2,000 kilometers off of Costa Rica right now, and our closest land is Mexico, which is about 1,000 kilometers to the north of us. There's a couple little islands here and there, I'm sure, but as far as the mainland goes, we're pretty far out here. So getting the signal to you, wherever you might be, can be a bit of a challenge. It's been working pretty well so far, but let's take a look outside and see what our weather's looking like.
It's gonna tip.
As that tends to give us the most issue. So let me see if I can pan our camera up here, or tilt our camera up.
Yeah.
It's looking like a pretty good day out there. So hopefully today's stream is nice. Well, I don't know, a little overcast over there. So we'll keep an eye on it. But yeah, we stream whenever we can is really the answer to that. Now we do have plans for pretty much just continuous cruises for the rest of the year. And again, I've posted up the link in the chats, both on YouTube and Facebook. I've posted up the link for the current cruise, but at that website there, schmidtocean.org, you can also find information about upcoming cruises, as well as review information from our prior cruises. And that's going to include, you should be able to look up cruises that occurred with our last ship, the research vessel Falcor. We, of course, now are on the new ship, research vessel Falcor 2. But
So many shrimp here before, I guess because it's a little warmer. Is that why, Monica?
we are hoping to bring lots of dives to you in the future. And while we stream these, we do, of course, also have the chat pulled up, both our YouTube and Facebook chat. So if you have any questions while you're exploring along with us, you can always type those in the chat, and we'll try to answer those as we can.
Maybe, yeah, if you think, yeah, that's super good, because we can always get a shot.
And then we will try to answer those as we can. The scientists here, of course, are in mission control with us to direct the dives, but we try to have them answer questions about their work as available as well.
That's ideal.
So a little reposition of the art there, a little closer, a different backdrop.
Really good.
Sort of a surreal scene.
For sure. I mean, that's a great
All right. The other thing to note is that yesterday Juliana fired up or left up the camera on Ascent. We had to end our Facebook stream, but we're going to probably give that another shot again today. Of when our stream is done over on Facebook, we'll try and keep YouTube running a little longer for anyone who wants to see the Ascent. Ascent's a little bit of a different game. We're headed up back through the water column, and
So odd.
you never quite know what you're going to run into, but
Little bit
yesterday we got a couple fun shots, some interesting jellies, siphonophores, little radiolarian sort of critters, and also a small, looked like perhaps even paralarval squid. So here we have some anemones, but also the riftia tube worms, the eel pout, and the vent mussel over on the left there. All right. So again, if you're just tuning in, maybe you're a regular and you're not quite sure what you're looking at here. This is a little sculpture. It's on. Actually, we were kind of curious the size of it, just for a scale against its backdrop here. That top platform is 8 by 8 inches. But this is a sculpture by Max Huber Schneider, who is our artist at sea for this expedition. Kind of traveling along with us on the cruise, able to see the science up close, be inspired by it. And we're just dropping this off here. We will be picking it back up at the end of the dive, so that'll be coming back up to the surface with us. But a nice surreal back shot there. The backdrop behind the art of an eel pout coming down, the giant tube worms towering over, sort of this examination of our sprawl.
It's like a nice cradle.
So also on this dive, we're going to deploy some experiments from students. And then we're going to locate a potential site for the deployment of our third experiment here at the Tica vent area on the East Pacific Rise. All right, so
Experiment from Vienna, which is, am I on?
yeah.
So, which is called Plant Animals, Meat Munchers or Leaf Lovers. And the students are from the Realgasse in Vienna, and they are about 15 years old. And they were asking the question or hypothesizing that anything that is meat-based should be eaten first, because this is the food the animals know, because there are no plants in the deep sea. But we put also as a control here 3 different items of plant-based food, which are chickpeas and nuts and a potato. And the meat is basically just meat or liver and fat. Most of the stuff we bought in Punta Arenas before we boarded the ship, and we kind of followed the design of the children So we will deploy one of those right where there's mussels and tube worms. So in a warm area, and as a control, we will find later a place on bare basalt where there's not so many animals, just that they can see whether they find it early or later, and whatever they prefer to eat first.
I think that's fun. One of the things, of course, that we always want to do is try and inspire a younger generation to science, and I don't know that you can get more inspired than actually having your experiment deployed at a hydrothermal vent. So that's very cool. Yeah, no, if I was a student and it was like, my experiment's going down, that'd be very cool.
I wonder if are they watching this right now?
They know I wrote it last night, so I'm pretty sure some of them will watch.
So just one or two.
If you see
Should I make
something in the chat,
Putting them both kind of side by side?
Yeah, if I see
No,
anything in the
other
chat,
person
I'll
will
let you know.
find. The next one is just a different experiment, but we would put next to it.
Oh, so it is going next to it?
Not this one, but the beans.
Yes. What I'm asking is,
Yeah.
we're trying to find a place for this. Do we need to leave room for the next experiment?
Yeah, but the next one is very small. It only has one lead and one bag and another marker. And they can be
Beanbag?
beanbag. Yeah, this is called the
This thing's
magic.
going.
Someone notes in the chat there, right, as we're talking
So this
about
would be
something like an opportunity for students to have their experiment on board. And also, you know, the fact that we have an artist at sea, and we tend to have these each cruise. There are lots of paths to ocean exploration, for sure. Even just amongst the crew, we have folks with really varying backgrounds that somehow have found themselves now on board a research vessel in the middle of the ocean.
Okay, that looks good.
Every once in a while, I think we'll kind of toss it around and talk about career paths and how people got here, and sort of what brought them here. And every once in a while, it's just an insane story that you know, at the beginning, you'd never think, oh yeah, that's going to end on a research vessel.
It's a good site.
We're doing the 15-second clip.
So just grabbing some highlight footage here
So let's,
of the
let's beat on the bottom.
students' experiment. And then we'll be visiting this site again at the end of the dive to recover that
see-
art. I'm not sure how long the students' experiment is going to be staying down here.
Fat liver. Then to the left is chickpeas. Then the nuts and the potato. Okay.
Okay, next.
Yeah, the next is in the Firebox 3. So this is a project which is called Magic Beans in the Deep Sea, and it has been developed by the elementary school in Piran, Slovenia. The children are 7 to 8 years old, and this is also in collaboration with the Marine Biology Station in Piran. The idea was that the children want to know whether beans can sprout also in the deep sea when there's high pressure and actually there's salt water. So, and the same question we do here, we deploy it at a warm area and then a control in a cold area. So they want to know, is seawater influencing the sprouting and also the temperature. And as a control we will do on board, and they did it also already in the school, the same thing, just without pressure. One set with seawater and one set with fresh water. This is their experiments. They're 7 to 8 years old.
Yeah, I would expect that the crab will probably come investigate. They always seem very curious about anything that shows up, honestly.
That guy's
So-
on it.
Yeah, I know.
He's
You
so-
see
he's
him on the
so-
left. He's ready.
Well, you gotta I love crabs. I'm surprised people don't dispose of more bodies that way.
I think they're just waiting for this big scary robot to get out of the way and then they'll come.
Is there,
And it's Thanksgiving.
is there one or the other, or are they both the same?
Monica, these are both the same, yeah, they can pick either one.
They can be eatable, yeah.
Okay.
It doesn't, yeah.
So we're grabbing these. So they do have, this is actually a good example here. We keep seeing little bucket lid markers around these vent sites, but they're frequently overgrown with, we've got like the stocked barnacles in the area. So this is a good representation of the sort of thing we're seeing before it gets covered up. But yeah, those markers certainly act as a substrate for some of the critters around here to settle out on. There's a question of what kind of beans. I know we have, there's some chickpeas on the left, but, or garbanzo beans, if you will. But I think these beans here, I want to say I saw the label and they were, there were some mung beans and looks like some red beans in there of some manner as well.
Get that inside and try to picture for a minute.
Yeah.
And a variety of beans
Yeah, just a mixed variety.
mix, yeah.
You'd buy this at the store, it'd be called mixed beans.
Garbanzo beans and chickpeas.
Chickpeas, garbanzo beans, I think are same thing, just names, yeah. You know that,
Yes,
John.
it's the same.
Don't do that. Yeah, that's fun to be able to bring an experiment from a really young audience and say, here you go, we've got footage of it, you can see it, and it's getting deployed right here at these just intense hydrothermal vents, honestly, kind of at the base of
Okay.
the tall worms. So that's fun.
Great.
So you want to zoom back in on that? Okay, let's grab the.
Yeah, we'll get a grab of the names.
Thank you.
Okay. I think this is good.
All right, so
Yeah.
we do have two of those beans. One will be deployed here, and then another is going to be
What?
deployed at a different different
Yeah,
environment.
but you cannot turn it.
All right.
Okay, so we leave this place now, and then we just find, when we go out of it, maybe on the top or somewhere, a place where it's empty, and there we will deploy the next two things like this. Okay?
Nice one.
Very cool.
So do y'all want a coffee or anything, or you'll do it?
All right, so we're going to move on to a different location, deploy the remaining student experiments, and then we'll be looking around for a good site for the experiment number 3.
It's just can be very close if it is convenient to set down for the other two. The site is fine.
Lots of folks hopping in the chat, so that's always good. Some excitement over the students' experiments, which is fun as well.
That's actually kind of steep right
Yeah, this is so steep.
Pilots are noting that this area might not be ideal for the experiments. It's a bit steep right here. We have seen on some previous dives setting things down, and then they just kind of immediately skitter down the slope a bit. So
RV bridge.
Go ahead.
Can we get you guys to switch the add orders off, please?
lots of squat lobster here. You can see them all kind of scattered out on the rocks.
I'm not worried about it, unless you were.
Nope, not at all.
All right, we're going to toss up a little map in the corner there. Lost our main cam. There we are.
You can grab first and
So you can kind of see where we are.
there's only two put them also next to each other.
Again, looking at the East Pacific Rise. And the area known as Tica Vent is sort of where we're around right now. Just to give you an idea of where on the globe we are.
Does not matter what is easy. So first comes
Again, it's about 2,000 kilometers to the west of Costa Rica, and about 1,000 kilometers south of kind of the corner, the edge of Mexico there. and this is Sebastian's 548th dive. So we're making our way through those dives. Question about the lights and when do we turn on certain lights, when do we turn off certain lights. Yeah, there's lots of material floating around the water, so pilots play with the lights to try and not get as much, you call it backscatter, where if you think about, if you're driving in snow or fog and you're not really supposed to put on your beams, your high beams, because it'll just shine right back at you. We run into the same sort of thing with the ROV, and so we have different lights that are at different distances and orientations from the camera, so that we can get as clear a view as we can in the cameras when we need it. All right, so we found a nice site for the remaining student experiments. We'll be placing those down here. Again, these are the assorted beans, including mung beans, and the students are interested in whether we can see any sprouting. We have here an area that's a bit cooler, and then we left another little satchel of these over in some venting fluid where it's a bit warmer. You can see down in the corner there the ambient temperature that the ROV is sitting in is is under 2 degrees Celsius. We're at about 1.89. I saw it flicker up to 1.9 there as well, degrees Celsius. When we've been measuring the venting fluids, so far we've kind of been measuring sites that we're looking at for the experimental site, but I've seen it get up to 10, or I want to say we even got up to 12 on a couple measurements, 12 degrees Celsius. So still maybe a bit colder than you'd like your bath water, but certainly the warmest water around for a lot of the organisms here. And more importantly, for a lot of the organisms, that water is very chemical rich. As it's going down into the rocks, getting heated, a lot of chemicals, a lot of minerals getting dissolved into that water. And of course, when it comes up, there are organisms that can feed upon all that material that's now in the water. Bacteria, especially, that will actually use that as a food source primarily. And then organisms that have relationships with those bacteria. Both organisms that house bacteria like that within themselves. So the tube worms or the mussels have these bacteria and actually get energy that's left over from the bacteria, getting their energy from that water. But organisms like the crab as well ultimately get a lot of their energy from the bacteria. They might eat the bacteria directly, or they might be eating worms that have passed away. And so it's a chemosynthetic system down here where it's all coming from chemical reactions rather than what we are most familiar with up here, where kind of all of our food, all of our energy that we're receiving in our food can ultimately be traced back to plants and photosynthesis.
Okay, so 50 saw next.
Yes.
The other thing that you can see at some of the vents, it's not all vents, but some vents you get the chimneys, right? The hydrothermal chimneys, the hydrothermal vent towers, and those are also a side effect of just how much material is dissolved into that water as it's coming up from the crust. This oftentimes very hot water in those areas hits the cold water, and you do get some like precipitation of the material coming out of that dissolved water, or coming out of the water that it was dissolved in, and it builds up these chimneys. We have someone in the chat saying that we had a reading up to about 20 C. That's possible. I haven't been around for all the measurements we've been doing, but we definitely do see warm water like that frequently when we're probing hydrothermal vents. And as I said, I mean, we can get much hotter. It's just this particular area and the site we're looking at, we're we're not looking to melt our experiments. Nice little shrimp hanging out in the camera there.
Nice. Great. Thank you. Take it out of that. So it's- and then we can move to the other one also. The other one we have already, no? Yeah, okay, then we just take this and we're done with here. Can you take a waypoint here, just for orientation, because if it's on the side, sometimes it's not so easy to find. It's waypoint 15, I guess.
It's been streaming just shy of an hour, so for anyone who might have joined us recently, this is live footage from 2.5 kilometers down on the East Pacific Rise at an area known as the Tica vent area. And we are just wrapping up the deployment of some student experiments, young students designed experiments concerning food and agricultural products and how they might be received in the deep sea at these hydrothermal vents. So we have on the left there some beans, and we also dropped off a couple or a set of these experiments over in some warmer waters, but curious about any potential sprouting those beans might have during their time here. And the one on the right there has some meats as well as vegetables, and interested to see how those are received in an ecosystem where there are no vegetables. There's really no vegetative matter. It seems like the chat is kind of betting that we're going to come back to a little party of shrimp or even crab over at the other site. I feel like that's a pretty decent bet, but you never know. They could surprise us. They could turn up their noses. This item that you see there, kind of in the background, looks a little rusty. That is a ballast weight from a prior expedition of some sort. Frequently, submersibles will have ballast weights that they use to bring themselves down to the seafloor to work down here, and then before they're gone, they'll drop those weights off to loosen or to lighten themselves, to make themselves more buoyant, and those weights get left behind, and frequently we'll kind of just see them corroding away. They are a metal that'll corrode in the seawater, and it can take some time, but ultimately it'll get done. So now that we have deployed the students' experiments, I believe we're going to be looking for potential sites for experiment number 3. That's experiment number 3 of this expedition. There you can see some other items left here. But experiment number 3 will be following form of experiments 1 and 2. If you've tuned in for those, that takes the form of a mesh box that we seal down over top the cracks where some venting fluid is coming up, and we're going to leave those in place and come back and see what the fluids may have brought up into the box, see if any fauna perhaps are being transported in those fluids as they travel below the ground. Here you can actually see experiments 1 and 2. So yesterday we deployed experiment 2. 2 dives before that we deployed experiment 1. And so these boxes, as I said, are sealed down to the seabed here. We actually had to block up some of the cracks on the seafloor, which we discussed it yesterday, so if you were around for that discussion, I apologize, but the interesting mix of off-the-shelf and tailor-made parts. So obviously the mesh box, that's not really something you're just going to go buy, is this mesh box with a weird little silicone seal at the bottom of it. But the material that we were using to seal up the cracks was just kind of silicone caulking like you would use to seal up the bottom of a swimming pool, or if you had an outdoor pond that perhaps the liner of it had gotten damaged, you might go down and seal that. So we were talking about that yesterday, and about how, you know, with this being at the bottom of the sea, it's difficult to do trial runs in the environment itself, but they did do little trial runs involving even just swimming pools or shallower ocean waters before they came out here to try and find the materials that would best work for their purpose. So we're going to come on down and check out experiment site number 2 here, it looks like. Again, the critters that we see most commonly around here, seems like we have these eel pouts. There's a little squat lobster hopped up on the bottom. Those are the more mobile critters, the crab and the eel pout fish there. But also we have the large tube worms that are kind of what a lot of people think of when they think of these hydrothermal vent ecosystems.
Mesh box 2. Also, die ist nur Fleisch.
This is the one further south.
This is the one that was stained yesterday, and you can see also flow. Can you make a frame grab of the mesh box 2 detail? Okay. Thanks. Oh. Okay, you have it? Mesh box 2. Okay, then we can move to the other one. It's also already a little bit.
You'll notice a little coloration on the mesh box here. That is due to a dye that we used to stain everything inside the box. The idea being that we would stain everything that was in the box at the time the box was placed. And now when we come back in 10 or 11 days and we check out under the box and we check out the items we've left in the box for organisms to perhaps settle out of the water onto, if we happen to see anything that's not stained, that would be a new organism that has shown up there since the box was placed. And since the box is sealed down, at least as best we can, to the seafloor, those organisms may have been brought to the site by the venting fluid itself. And for organisms that don't settle out, someone said, well, what if you lift the box up and everything just kind of swims out if it's up in the water? For things that don't settle out, they actually discussed this yesterday briefly. We are going to pierce the side of the box, and using a little suction system, we are going to suck out the water for a while from the inside to just try and suck up anything that might be just still drifting free in the water. And then after that, then we'll lift the box up. There's some sponges underneath, which provide sort of a little porous substrate for organisms to settle out on. And there are also some like acrylic plates, basically, that Monica Bright's actually had success with getting the tube worm larvae to settle out on in the past. So this one here is box number 1.
It also has a color. It depends what's in the background a little bit. It depends a little bit if you go closer, then you see it's also a color. But I think it depends also a little bit on the. I don't know if you see through or really you see maybe a little bit of the background. I don't know, because you cannot see our deployments in there at all, no. But I think it's great. It looks different, so fine. Okay. No, I think this is good. Just to. I still need
Can you zoom in a bit, just have a close-up of the silicon to see if there's any change there?
You mean on the bottom?
Question of whether or not the dye could end up staining organisms that show up after the fact. And so that's one of the things we did yesterday was we spent about a half hour pumping dye in, and then we sat there and allowed the dye to stain what was in there, and then we once again pumped the dye back out. So the dye inside should at the very least be diffuse enough, and it is a mesh box, so it'll be getting ever more diffuse over time, that even if a new organism did get slightly stained, I would assume it's not going to be completely stained like the things that were present when the box was deployed. So this one's been there for 3 days now, I guess. Experiment number 2 was deployed yesterday, and it definitely looks like there's some growth on the box. So it'll be interesting when we collect that up to see what we have.
Finish your homework assignment.
All right.
That's adorable.
I need more. I think I wanted to write another WhatsApp first. I said, Jesse, we need the one tomorrow, and then I didn't send it off, so I wrote it together.
All right. Just checking out, just getting some imagery of the box as it currently is. Again, these are going to stay here. We'll pick them up before the end of the cruise, but they're going to stay here for a while. So.
Go in there.
No, you need the box, the big one, I think, together.
No, it's not about the big one. It's just the site is very. There's very many high and low structures, so it's very difficult to get in with the ROV.
Yeah.
And if you can get in, then you are flying around a little bit.
Currently, it sounds like the scientists are discussing where experiment number 3 might be placed. So.
We looked closely where we found small ones, and I think this would be probably still the best I can get you and write you when we start to do this. But it's a little while yet because we have to do first the start the experiment.
Any live worms would be fantastic.
Okay. Yeah.
I have a question.
Mm-hmm.
Do we know where we're going to use the rock breaker? Which
Yeah.
location? Can we go to that location and put the rock breaker, even if we're not going to do it right now, just put it? The reason why I'm asking is because usually the RV's light.
It will be used in this area.
Okay.
So
we can stow it here, maybe?
you can. Here we would like to try it also here, but
Okay.
it has to be not where we chose the site free location, and it cannot be close to the boxes. And
Let's just first find the spot free, decide on that, and
let's
then try
we
out.
find the spot, and on that spot we will not try it.
No, then we go to another
Yeah,
place.
okay.
Okay.
Let me see. I just look a little bit here,
Sure.
over there, because if there's nothing over there and it's flat,
One could probably go to the waypoint 14.
now 14 is exactly what it's 14 is what was printed out as this. Andre, you just gave me 14, no?
All right, so different map here, taking a look at the bathymetry of the area. And you'll see where ROV Sebastian is currently located. As you can see, there's a nice little split here in the terrain. And so bathymetry like this really assists with planning out dives. This isn't so much being used by the pilots actively to navigate around, but it can be used for sort of planning the dive, understanding the terrain, that sort of thing. And then during the dive itself, we're using more just a traditional top-down map.
Bigger view, and then you can choose a spot. And then, it's hard right now because we're so close to everything. Okay.
Real neat feature here on the bottom of the ocean. Again, we're about 2.5 kilometers down, and this feature is found about 2,000 kilometers to the west of Costa Rica, 1,000 kilometers south of Mexico.
Usually this is the best for like looking at a broad area. So I'll have to do as much as I can.
All right.
What's that? Anything you like.
Getting a wider shot here of experiments 1 and 2 in their places on the seafloor. One of the challenges we are going to have on the recovery of these two experiments is that we want to also collect a bit of the rock substrate underneath the boxes. So we do have sort of a chisel / pry bar that ROV can use, but some experimentation with that over the past few dives has shown that the ground here really does not like to come apart in a nice piece. So I'm not sure if we'll be practicing anymore, or if we're just going to kind of try our best and scoop up everything we end up getting.
It's that's where you resume.
But it certainly crumbled quite a lot when we were testing this out on another area a few dives back.
Just north, yeah, it should be right there. That's that muscle work, not muscle.
Kind of fun here is you can tell where cracks of venting are, because there's these lines of the larger Riftia tube worms. And then the large vent in the background there, of course, is just covered in those worms. The smaller worms seem to not care quite so much, not be quite so picky. Those are a different type of worm from Riftia, but still little tube worms. All those little white doodles all over the ground are worms of their own. And then the squat lobsters, being mobile organisms, they'll cruise around wherever they would like. But obviously, if there's nothing for them to eat in one area, they're going to scoot to another. So interesting to use the biology of an area to determine the geology of an area. Sort of brings to mind if you were along for our last cruise, the Octopus Odyssey, where we were looking at the octopus nurseries, where female octopus were actually brooding their eggs along hydrothermal venting areas. Different venting areas than we have here. Those didn't really have the large Riftia tube worms growing or anything, but scientists were almost using the presence of the octopus to be an indication that there might be venting right where that octopus is. Oh, there's a squat lobster saying hey. And for a cruise like this, lots of different disciplines of science, lots of different backgrounds and specialties in science. When you're visiting a site like this, you really want to bring anyone who could benefit from that along and try to get a whole picture of the area. Geological, chemical, physical, and biological.
Somewhere in here.
We have two things, not this and this, probably is it, what's it? But it's a different angle. I don't know.
So this is another angle?
Yeah, but this is looks more. I think it was this here. And then we said
Again, we're kind of just looking around for a good site for experiment number 3. And so the sort of things we need it to be obviously an area with some venting. We do need those fluids coming up from below the ground, but also, as noted earlier when we were deploying the students' experiments, the terrain around here isn't always necessarily level, and that can pose its own issues. So we do need level terrain, and also aside from the cracks that the venting is coming from, we also need relatively flat terrain, because we do want to seal these boxes down. So I'm looking for all of the features to kind of align in that perfect little mix that will allow experiment 3 to be properly placed.
this is in what I is this deep. Yeah, we have it. I mean, we need to take time for this. It was in not a perfect place anyway, so if we see another one.
Can I look at something that I think
Yeah,
might be?
yeah, yeah. I think I was on the other side.
That's exactly what I'm looking at.
No, this is much bigger than. Can you print this picture so we can have it on front of us? Does this one take the
Yeah,
weight?
exactly.
Yes. Because. Huh? This here, you mean this here? So that we could collect the next one, no?
You can move the camera if you'd like. Go, yeah, good.
Okay. You have
I see someone asking about the experiment. So experiments 1, 2, and 3 are these boxes that you may have seen around.
You have a crack here.
Let me look real quick.
The crack, this crack should follow over there. So basically you see in the middle of it.
So right now we're looking for another site to place a box like that one. That'll be experiment number 3. The one we're looking at there is one of the prior 2. And the idea here is that a lot of these venting communities, of course, they have similar organisms, but as we just noted, the worms, these large Riftia tube worms like the red tube worms in front of us here, they really need that vent, right? So they can't really live without it. They do require it, or rather their symbiotic bacteria require it. But how do they get from one vent to another? How does the community of worms spread between vents? And obviously, one way could be up through the water column. But we're also we're investigating for this cruise the possibility that they're actually traveling down through the ground, because the hydrothermal fluids that are venting up from the ground, they do get drawn into the ground at other sites. And so if the larvae or even the gametes of these organisms get drawn into the ground, can they make it through the process of being heated and ejected out at what will then be a venting site? And if they do that, is that a potential route that they might be traveling? So these experiments are designed to seal a mesh box over top of some of these venting areas, and then we applied a dye which stained everything in that area when the box was deployed. So all of the animals, the surface under that box, it all has this stain on it. And then we're leaving that box in place for over a week. We'll collect the box back up at the end. There's some items underneath as well that have been found in the past to be quite successful at allowing these small organisms to settle out of the water onto a more firm surface. So we're going to collect these boxes back up and see if anything has settled out that doesn't have that stain, meaning that something showed up after the box was placed and sealed to the seafloor over top of this venting area. So investigating whether or not these organisms are actually traveling through the venting fluids below the surface of the ground. And this frame here that you're seeing being held right now by the manipulator, that is the footprint of the boxes. And so we can use this here to sort of measure out and plan where we want to put experiment number 3.
This one, you can take this one out, this one.
For those like as the last two, like that's the tubes, so they can just try to pull them out.
We will try to pull those in this last one. But we
It might be a little easier to see because we're looking down with this view. So I don't think they're too concerned about having the whole worm. They're more worried about the base. So see how that
You can try this one also,
you're pushing this
the one behind,
There you go. Right there. That's
because maybe this is more
right
confined.
there.
This,
So that would be
Let it loose.
yeah, I think this is very uneven. Yeah, sure. Here.
Be fine, because I think the inner one is like laying on the. No?
No, this is like all.
Yes, but the
Thing here.
can you zoom in?
Yeah,
That,
I can zoom in.
good.
I think that the part that's the inner part, I think, is probably touching the rock. And the silicone can cover like up to, like a centimeter easy. Can you have a look from the other side? Like from that we see how it looks like from the inner side here? So basically a view from there.
The metal plates that you spotted on the porch there, those are going to be involved in rock collection, but not necessarily as ballast, although certainly a metal plate will act as some manner of ballast. But those are the rock breakers that you might hear
deploy.
Monica and the pilots
I
discussing.
don't know, is it this flat here?
Do we want? So I just suggest that we look from this side. That we also see how how the frame is positioned.
Okay, not 3 people cannot say always the same. So let's deploy first, so we make it easier somewhere. The rock, also the rock cutter. I'm not convinced I like this spot, but let's just deploy this now. And then I think here over there it's more flat to basically deploy it, because this goes down again. And this is also a lot to recover, no? I mean, let's see.
Got a question about all the squiggles. So all the little white squiggles or doodles on the rock here on the seabed. Those are all worms. They're little tube worms. So the white structure is actually their tube that you're seeing. These are a different species than the large tube worms in the back, the riftia tube worms that are kind of archetypical for these venting communities. And again, on those large riftia in the back, the white portion is the tube. The red portion are the gills that they can extend out, but they can also retract into their tubes to sort of protect themselves.
Yeah, I'm tempted to pick up a little bit and back up.
Sure.
That way we're not, if we pick this back up right next to all this stuff.
Sure, yeah.
That's the concern.
Just find a good spot.
That's steep.
That's steep, no?
Let's go off to the right here. Yeah, go for it. I think this will be alright.
This
Nope.
is steep.
You're alright.
Yeah. Where?
Not heavy no more. What? We're not heavy anymore.
I wouldn't guess we would. It should be right back over.
Yeah, we're fine.
See the frame there. So what they're wanting to do is come around this way. They want to see under it the other direction. So right around, face this way.
Got a bit of a pilot handover happening here. Pilots Jill and Alex are handing over to Chris and Russ.
They want to look at the box.
The frame.
The science seat right now, we've got Monica Bright in there. You've been hearing her. And then my name's Alex, and I'm a multimedia technician on board for this cruise. Yeah, the weight of that the rock breaker plates there, probably about 20 to 25 kilograms for the whole package there. So again, that frame is kind of used to judge the size of what the experiment will be when we deploy it here. So kind of getting different angles on it, just make sure everything is looking suitable for the experiment. As you can see, there are cracks that extend beyond the frame. And that's all right, as long as there's not too many of them, because we will use like a silicone caulking material to block those up.
Can I use the camera?
Oh, yeah, of course. It's all yours.
Monica, do you know what the like that ash-like scaling is on the mussels? Is that bacteria or?
No, this is from the Büssel. Also, this is just the super outer layer of the mussel that comes off.
Oh, okay.
I mean, and some is Büssel's thread,
Okay,
where
so
they hang on each. So basically, the mussels often hang on each other.
yeah.
So what you see is like part of the Büssel's thread of another mussel on the shell of the mussel, like this here.
Yeah, so something
They're
of the
hanging, or they were probably hanging, and part is their own Büssel's thread.
something of the Bis's thread and its adhesive. Okay.
This is upwards now, but I think it would go down when the tubums are taken out, no? Here. So this is not like completely flat.
You see on the left corner.
Yeah. But it is probably better when we cover so we take out a few tubums.
Yeah, if you
Because now it's
look at our
on
sit
to-
camera. Look at the sit camera. Definitely just land right out there, so we'll go down a little bit there.
It's being on the tube right now.
Yeah, that's why I say if you take it out, then it's probably flat. This maybe has to be shifted a little bit towards us now, but that we can play with the little thing when we. I see a small one here, so I think we can take this side, or we could take this
What
side.
I would do is when you choose the side, like take out these tubers, but also these muscles here.
Yeah, you
Because
can take
otherwise
out more.
you have too
Yeah.
little space to play around. Because the inner side is a bit larger than the frame.
Okay.
Yeah, so if you've ever seen mussels in a tide pool or more along the shore on a rocky shore, they can of course secure themselves down. They don't want to get moved around by the surge, by waves, anything like that. So they attach themselves down with a strong thread-like adhesive called Bissell thread or Bis's thread. And I had noticed that these mussels here, I mean, obviously we've been touching them with quite a strong robotic appendage, but they don't seem to adhere quite so well. There's still some adherence, and so they do have Bis's threads. And Monica Bright said that sort of scaly nature on the outside could be remnants of the adhesive there from other mussels or that mussel, also just parts of kind of the outer bits of the shell that can slough a bit. But yeah, certainly different from the business threads that you might be familiar with like just black mussels along the coast. Here, obviously, the mussels don't necessarily need to worry about the waves pushing them around so much.
From here you can
Bit of a different environment for sure.
Okay, this is all. Okay, then we go on the other side, because I think from the other side you see all three better.
Monica, can we go up and then we're up, take a
We
frame
have to
of
go
that
up anyway.
S, and then that we have an overview of like where all three boxes are.
Oh, on our rear camera, got a little. Let me put up a different camera there. On the rear camera, we just have a little squat lobster drifting by. Every once in a while, you'll see one kind of like skydiving out of the water above us. And frequently, we'll have one kind of hitch a ride on the ROV for a while. You'll see them scutter up into the water column. A lot of times when we draw close, a mechanism to get away, but also just rapid movement, rapid relocation. If they can get themselves up into the water column and spread out, their legs kind of just drift. The currents can carry them along as well.
So is this like the largest onboard gravity that we'll find, or
no, yeah, this is a lot of such several such places here.
We're going to be taking water samples from here as well?
Mm-hmm.
Alright.
But
I'll set it up straight then.
we will collect basically part of this one here. So the water sample will, actually I think the water sample we can take here because this one is big enough.
Okay. Should be able to reach that one, no problem. Alright, so. Temperature first? Yep.
Mm-hmm.
Work check for a little bit?
Yes, please.
Are you happy?
All day, you know, they just kind of like this.
Can't really help you with the. Which one? It's not, you gotta really do the others. So.
Oh, good true.
chin, right, stay right there. Okay. Alright, so it's
All right, so obviously one of the things we want to know about this site is what sort of venting
bungees wrapped around.
we have.
No, it's not.
So we do have a temperature probe that can be deployed, as you see here.
It's just the way it is.
Alright.
Are you going to torch blocking?
All the way in?
Yeah. It's hard to get down there. I'm not free it. I'm ready to go. He's doing that myself.
Sit. It's too far. Spot underneath the tile block. The monkey's fist is just tied up and really small just to keep it from going through the eye.
There we go.
All right, so again, heat the temperature probe here, high temp probe. It can be used to measure the temperature of the water coming out from this little vent here in front of us. Although the worms themselves are a good indication of there being venting, we just want to know what the temperature of that fluid is.
What's that?
I have no idea what's going on with that thing.
I don't know, it's all, it's, okay. Maybe, so we can see it.
So down on the left there, you can see the temperature coming or being read by the probe. Just to the left of that, it's a little difficult against the white worm of the background, but it looks like the ambient temperature just where Sebastian is sitting now is about 1.9 degrees Celsius. And the temp probe itself is reading 9, almost 10 there. The large number is the temperature, the most recent reading, although we're only pulling it for this overlay every once in a while. And then underneath that is the highest reading of the past 5 minutes.
somewhere. Yeah, this is. You can go deeper. I can see it. Get away.
That's good.
Yeah, but you are basically quite. You basically you can go here a little bit. Yeah, right here. Okay, wait.
Good and warm right here.
No, wait. Okay, somewhere here. 22 we have had already somewhere. You can. I think it's. Maybe it's hotter here. I can shift a little bit here, but.
There we go, another reading up above 20 for this particular area. Down at the bottom, center frame, you've actually got this longer worm kind of cruising in. So
Maybe
not all the
over
worms
it
around
was
here
over
are tube
more
worms.
warmer, but it was a. No, you can. Okay, I think it's fine because it's like almost 23, 22.7 is the maximum. So it's difficult to put the probe between the muscles or everywhere because you can really not see where you are.
Bring it back up.
Okay, yeah. I mean, if we want to take the water sample in here, that would be possible, no? But then we wait,
A little bit more if you
we
need
make
it.
the water sample first, and after this we make the removal of the other stuff
From the frame.
from the frame. Yeah, now remove like the tube worms and the muscles that are,
Obvious.
and then we take more off from this side chest, where we have more sample,
There you go.
because it's better to take the water sample kind of undisturbed.
I need to spin it 360 to get it on the other side of the cable. You know what I'm saying? There you go.
Hold it there where we have measured.
Oh, no, just twist it like that. That'd be fine. Let's see. Come back in.
Yeah, I think that's basically.
Yeah, that little crawling worm, some manner of polychaete that we saw cruising in there.
For the shadows. Down more. Looks like everything's caught up, so it's not gonna, I don't think it's gonna spring back, but you can try it. If you look, it's caught right It is what it is. If it falls, it falls. We'll know where it is. Alright. Do you want to do the water sample now? Or?
The water sample from here,
Okay.
kind of between them.
Just remember. Doesn't going to be beneficial, but it is. That was possible.
All right, tossing our globe back up there. Just to kind of show you again our relation, where we are and where we've been. So again, we are at the East Pacific Rise. This is currently the site of dive 548. Near the Tica vent area. And to give you just kind of an idea of where that is in relation to the coastline itself, we'll zoom back out here. You can see we are south of Mexico quite a ways there. Roughly 1,000 kilometers to the south of Mexico.
But how can you cannot set it here? I would like to set it here. You think this is possible to change? Look at this.
On our way out here, the port that we were actually stopped in was Punta Arenas in Costa Rica, which is about 2,000 kilometers to our
Stop
east.
a little bit and let me.
So we traveled out here from Punta Arenas. Out to the East Pacific Rise. And that's the bathymetry that we've pulled up as well, occasionally, where you can see the interesting feature here. On the screen right now, we've got a nice little shot of the venting fluid, the sort of stuff we're looking for, which you'll frequently hear described as shimmering water. So that's actually the water that's coming up from below the ground here, heated water, carrying with it all sorts of dissolved minerals and chemical composition. And yes, I believe indeed this this clump of worms has absorbed a marker or two.
Ah, scheiße, those are things.
This is deployment here. Yeah, I'm not.
Is this flat?
Should I try to put the
Like-
the frame?
Here,
Place it.
cross over it, here. So to have get this one inside.
It's at an angle like this, but not like pointy, so it'll be.
It's not probably more than this here because this is okay, but I'm just curious.
I would say it's probably a little bit less than that. It's gonna be a little bit flatter than what we're on right now. Than what it's on right now.
Currently, pilots are discussing where we could put
No,
this frame.
we cannot take it because we will destroy it in the end, and this is the deployment. But with this, we can take. I mean, I like this, but I don't want to because we will recovering this. I destroy the deployment of the other. So this is okay. Where are we? Ah, yeah, water.
We always like a water sample.
Sorry.
All right, so we're going to grab a water sample here.
Where's the marker going to?
Ja, inside, aber wenn ich da rumreise und tue, dann ist
And if you've seen the previous dives, right, this is the same setup that we use for both collecting the water samples, but then also for deploying the dye. We use a different bag, but there is a bag on the back of ROV Sebastian here, the aft port side,
yeah, where basically we had the
right here. And that
Kind of
bag, there's a
here.
tube coming out the top of that. That leads back to
going-
this probe. So what we're going to do is kind of get this probe in a nice position,
yeah, yeah.
and then we will actually turn on
I
the
saw-
pump
yeah,
and
but
start
we-
filling that bag
Wait a
up.
second. Let me see. If we could see it now. We could start here, and then when we see that it is pumping, oopsie, sorry, you just go down here. Because I think it might be easier to speak, because when we
Yeah. All right, I'll leave this
Yeah.
for water.
So the probe is in location there now. We're going to use the other manip to turn on the system.
Then we take it out.
Is that?
It's the one that's gonna take it out.
Yeah. So we go on first. Just that one.
first the on, no?
Yes, yes.
Okay, yeah. We have two different colors now.
So it's just notice and take it out.
Who did this so nicely? Green on.
Juice. Yes.
This is right where the temperature.
5 inches away from it. Give it 2, you got a pretty good view out there.
So we're just turning the system on now, and then underneath you can see another switch there to either push water out towards the experiment if we were filling it with dye, or towards the bag to take water in. And so we'll turn it on first, and then we'll kick it over to experiment side real briefly, just to flush out water that might be in the tube already. and then we will kick it back over to bag and begin filling the bag itself.
More. Good.
A little bit too big,
Why?
because I mean that's too much. Okay.
It's not too much.
Can you put the zoom to the pistol? Yeah.
Zoom to the
Just
left. Oh,
Just we want to see something.
yep.
Just raise the arm up so you look at nice. We want to see something. Very close zoom.
Whoa.
Okay, it doesn't work. Didn't work, okay.
Why?
You see why? Look at
It should come out now.
You see this? Hair. This is my hair.
Yeah.
Hair. I put here.
Yeah, okay,
that
I see.
want if it work
But
or not.
but right now you.
Now it not work.
Yeah, but right now you should have come out, no?
Yes, of course. No,
Okay.
because it in the back. In back. No.
No,
It was in the middle.
Yes.
It was in the middle.
it's in the middle.
In the middle.
Yeah.
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 Okay.
I see this here. I was thinking that this, where we can see it, what happens, but
But it's work when it's work.
it's like right now you're in the middle of the other one, no? So
Usually start working here. Okay, put in X and then back.
yeah.
All right. So past couple of times we've had to toggle this one on and off a couple, but it's been working.
Okay, it's air there.
One of our issues, of course, has been determining the flow. So as you heard, there's a little hair there stuck to the tape, so we can see if it's flowing or not. Sometimes the simplest solution, I suppose.
I don't think
Yeah, we know,
I
but
had
we
enough power to
switch.
move that on my head, but
No.
but mine it was a little crazy.
I want to see now.
Mhm.
Can you again zoom?
All right, so we'll
But,
take a
yeah.
look back now. So it should be pumping water out of the bag,
What happened?
but in the past it seems like we usually turn it from experiment to bag and then turn it off and then back on again, and that'll usually do it.
Yeah, it is.
Yes.
You see, it's working now.
I don't know.
Yes, it is.
But it's not getting out.
It's
Out.
in.
Now it's out.
No, it's out.
Yeah,
Now
it's
it's
on.
out.
It says here the direction experiment.
X.
Right. Okay.
Back is back.
Okay.
Alright.
I think
Okay, let's go
experiment
to
and
back.
bag is stupid, but yeah.
Confusion over the labels here.
The others are not confused. I'm confused. just to clarify.
It's very clear that we go to the bag, it pumps into the bag.
It's worked too much.
Yeah, but
Already,
we were
5
working.
times.
We were working on this on a different thing, no?
But
And it was changed a little bit.
I put in my mind the put back.
Yeah,
It's back.
always one arrangement of
Reminds me of that.
equipment or experiment, and then once it comes to the ROV, sometimes it needs to be changed, and so designs are a little different from what was anticipated. When scientists are preparing for these cruises, we can provide some ideas of the ROV. We can provide measurements and some schematics. But, you know, at the end of the day, when it gets here, sometimes it needs to be modified. And so you never quite know what you're going to wind up with as far as your arrangement once it gets to the ROV. So we'll take a look here. The flow again.
I switch it on.
Powerful. There's a couple. Here's like flow in there.
I just started here. We can wait 5 minutes.
So we're just going to give a little bit of time, it sounds like, see if the bag inflates any noticeable amount. But the previous couple times we've had to kind of toggle it off, toggle it back on. And then it usually seems to fire up after that. So something about the arrangement.
38, yeah, right? Yeah. 38 is basically blue bag, water.
And the bag ultimately holds, well, it holds 55 liters, but we have gotten it up to about 58 liters or so, I want to say. When they're sending down the dye, it usually has 55 liters of dye in it.
Before we put it down, you want to wait.
Like yesterday, off and then again.
But it's not working, or?
I mean, it's not.
I think it's pulled in. I mean, your hairs are pulled in here.
Well, this is the picture that I took, but it's going
See?
very slowly. From the
But I think it is not
moment,
fast.
so I just need to cool.
Yeah.
It must be more air inside.
There is not more here. There's one more. But it was like 1, 2, 3. I can count them.
Got a very nice zoom on the gills of the Riftia tube worms here. A texture that I think as a kid learning about the hydrothermal vents and the large worms here, that's not really the texture I ever imagined for the worms.
Several put
Well, it's working.
Yesterday we took
Just
off
wait
all
there.
and took 2 weeks. Yeah.
Now this is basically
To get rid of it.
Say,
Yeah, I don't think so. Looks the same. Yeah,
yeah.
so.
Question of what dye we're using, and I think this came up briefly yesterday. Yeah, it's a pretty standard dye for staining of microscope slides. We're just using 55 liters of it, and yeah, it was a non-toxic dye that will just disperse in water. We do suck it back up into the bag, just so we're hopefully don't have too much lingering dye inside the mesh box itself. But then that dye is released before we get to deck, just as we're coming up through the water. You can imagine all of a sudden a very large staining red mess in the hangar of Falcor 2.
Yeah, let's try to switch on all of
Yes.
All right, we're gonna give it the IT tech go. I guess that's like something like an ATM machine. We're gonna give it the old IT go of turn it off, turn it back on. Which has seemed to work in the past, so it might just be a thing where it needs to be in either bag or experiment mode before it gets turned on. And since we always start it in a neutral, it just never gets going. But we'll take a look at it.
No, I'm trying to. No, he's supposed to buy the place now. Switch on.
Alright, so we'll toggle this back on and then take a look again. If you're just joining us, we are currently streaming from 2.5 kilometers below the surface of the Pacific Ocean at the East Pacific Rise, at a hydrothermally active area known as the Tica vent area. And we're in the process of preparing for the deployment of an experiment tomorrow. So today is kind of preparation and scouting. Make sure this area is gonna work for us. And then tomorrow, hopefully we'll come on down and we'll drop off our third experiment. But right now we're just toggling on a device that's going to sample some water for us. If you've never tuned in for one of these dives before, this footage is coming from a remotely operated vehicle. So this is think of it as a little robotic submersible. It's not human-occupied vehicle, well, something like you might have heard of Alvin. But there are folks up on the surface vessel, research vessel Falcor 2, 2.5 kilometers above this remotely operated vehicle, and they are controlling it over a long umbilical tether. So we have all sorts of controls up here. The manipulator is controlled on its own controller, and then the ROV is piloted with a different controller, and the cameras as well can be tilted and zoomed and panned around.
Yeah, I know. It just keeps rotating.
you come down underneath it. Come out.
While we're toggling this on, I'll take a quick look back outside. I know we had a little bit of overcast looking weather kind of off in the distance.
Try to come underneath.
It's looking pretty good out there right now. I think off that way is where we had the overcast earlier, so nothing too bad. That's one of the issues we can face out here is inclement weather can make streaming this out to folks at home more difficult.
Can't get the train just gently touches. Not his face is twisted, so I see it's going to show it. Don't want to twist it the wrong way because then it's
So
there.
then I'll just leave it there. It's you can grab it from the bottom if you need to, or pull it until you can get it on the side. You know what I mean?
The switches that you can see behind here are actually part of a different method of collecting water samples. Those are the triggers for Niskin bottles, which are kind of these little tubes, open-ended tubes with spring-loaded caps on either end. And when we push that trigger, those caps will snap shut. So at any given time, those tubes have water flowing through them or moving through them. And when we trigger it and the caps fire, it traps a sample of water from that moment, from that depth, from that location inside the tube. All right, so it looks like it might be pulling in a bit more now. So again, we're trying to draw water into this little bag down here in the lower right of your screen. That bag is mounted on the towards the rear, I guess. It's within the structure of the ROV, but it's towards the rear. You can actually see one of the thrusters of the ROV there above it.
Working?
And it was explained last time I took one of these samples, right? This water, 55 liters, it just sounds like a decent amount, but it gets divided out amongst several science teams. Teams looking at chemical composition, biological composition, microbiological composition, just looking at all aspects of this water. So it gets used up pretty quick. Yeah, so folks here on the ship have kind of still frames of what it looked like before we turned it on, and it is a slow process, so we'll just compare those frames over time and see if the bag appears to be inflating. You'll see though, once it's full, it is quite full. And then we can transport that back up to the ship when we recover our ROV Sebastian. Again, this is just preparing for the deployment of an experiment tomorrow. So we are hoping to deploy our third mesh box experiment tomorrow. That over there is one of the previous two that we've deployed. Again, that box gets sealed down to the seabed. We actually fill the cracks on the seafloor that might extend underneath the edge of it. We fill those, do a little bit of caulking to just block them up, and seal the box down as best we can. And then another box goes on top. We pump the whole system full of a staining dye, like you would use to stain a microscope slide, for example, just to make sure that everything that was there when we deployed the box has been marked. And then in over a week's time we'll come back, we'll get the box, and we'll see if anything not stained has arrived in the box.
So do you want to do?
Which one do you first?
Which one first?
Export. Export.
X.
Export.
All right, I'm going to hop away for a few moments here, but I'm going to hand it on over to John, who yesterday ran a nice little round-robin interview circuit in here. But I'll be back in a bit as they continue to work on preparing the site and collecting samples for experimental site 3.
In there.
Mm-hmm.
Yeah, leave the arm up here and just check.
Mm-hmm.
That's it.
Move that a little bit.
The two bombs.
Thanks, Chief.
Thank you.
Move that a little bit.
Try to help make them.
No. 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 I think it's not working.
I have a picture. Zoom it.
There's
I mean,
no-
Zoom. Yes. What's going on?
Let's try on off again, I don't know.
Off and
And on again. Or
Well, good afternoon, good evening, good morning, or good night, wherever you might be tuning in from. My name is John. I'll be sitting in for a little while here, taking over for Alex while he takes a break. He's the multimedia technician who has been with you all morning. I am the lead technician aboard research vessel Falcor 2. So I'll be able to add a little bit of commentary here. But, as our ROV pilots toggle the on and off switch for the pump to do the fluid sampling. If you're just joining us, you're watching video live streaming from ROV Sebastian at the bottom of the East Pacific Rise. We are 2,514 meters beneath the sea surface. And we are off the coast of Central America and a little bit closer in proximity to Mexico at this point.
Oh, that was too much. So I think it's backwards.
So our chief scientist for this expedition is Dr. Monica Bright, and she has just gone for lunch. But one of the co-PIs, or principal investigators, is Sabina. They're in the midst of working out this issue here, so we'll let them chime in a little bit.
Okay, start.
third try.
Look at this right there.
Looks like it's going in. Is it the particles?
Yeah, no, I think that you cannot really see it with the hair also because the vent fluid is also,
But I think
probably the vent fluid is stronger than the pump.
His hair is just
Too strong.
too strong and thick and family.
But I
No,
think
wait a moment, it's like it just started.
But I think that it's
Pump very slowly, very slowly.
yeah, but
Yes.
I see the particles. Some of them look like they're going in, but I don't know.
But look at the picture, it's changed.
Oh yeah, Big chunk of change.
Yeah. So see a little bump there compared to the here,
Yes.
or not? Here's the picture.
Exchange change.
I think it's going.
You can see here, just in the inset, we've got an SD camera pointed directly at the bag that we're intending to fill with this hydrothermal vent fluid.
So I think it's
So it is designed to kind of fill slowly for the dye experiments. If you've been joining us the last few days, it takes approximately 30 to 35 minutes to completely fill
It
or
might be
expel
like that
the
back
70
yeah,
liters
it's
that
filling
we
up right there.
can carry in this
Yeah, like
bag.
this area right here.
It's not
Yeah,
immediately
yeah. It's a
apparent
little
whether it's
bump there.
working or not,
Yeah.
but hence the little piece of hair
third
that's been
time-
taped to the end of the tube for sampling.
When
Or,
change
if
this
it's well-
distance, we will change this maybe it's work.
Yeah, that's true.
Okay, it's work.
Okay.
So,
I see we'll go down deeper in that.
Yeah.
let me start the arm.
A little bit, yeah. Just like a, like a, yeah, 2 centimeters, 2, 3 centimeters.
So one of our ROV pilots, Russ Cofield, is stowing the starboard manipulator. And switching over to the controls for the port manipulator so that he can move the probe to a more ideal situation or position here. See the rift here
That's
retracting
good.
when they get brushed by the
It's good.
end of the sampler.
Stopped. And it's secure.
With those in position, you can freeze the arms that it stays locked in that position. And we'll wait for that bag to fill up. And for anyone who's curious for where we might be in the world, wherever you might be joining from, there's just, you can see the gray line there, the track line that we took from Punta Arenas, Costa Rica. It took us approximately 6 days to transit out to this work site. As we zoom in here, hopefully it doesn't jitter too much on it. The high resolution multi-beam data is inset there as well. Here we are. A little bit more context, we can zoom out here.
I guess definitely working. Yeah, I can see.
Just have to be a bit patient.
Yeah, that's true.
Relax.
Yeah.
Take it easy.
What is that? There must be a reason to make lies like this.
It's weird because every time we've done the dye,
Yeah.
it's like the first time.
Yeah, but because I think the problem, so we want to get like the air out, like when we do it like this, like the bag is like really empty with a kind of a vacuum a bit. Of course, you get a bit of air, and then I think it makes it difficult to kind of, probably it's that the valves are blocked a bit. But when the bag is filled with all this this dye, I think there's no reason that would stop it to go out.
That's fair. I'll buy that for now.
So yeah, this is how I would, and I think it's just a matter of like a few times like changing direction to kind of release any blockage that we would get because of the pressure difference. So the pump is working. It's just I think a matter of 1, 2, 3 times.
Yeah.
Yeah, there's a question on YouTube there about what the ship does after the ROV comes up on deck. So from the inset that we had up there a moment ago, you saw the ship track line. So there are gray water and other things that we must pump out of the ship. So we leave the work site at night, but very slowly, so that we don't disturb the scientists who are working away in the labs. We don't want them rocking and rolling all over the place. So we'll just transit out far enough away that if we pump anything out over the side, that it doesn't come back to the work site. But essentially, we're just drifting at nighttime, and then firing up the propulsion system and heading back to the work site in time for our early morning deployments. So the ROV team has been coming on at 4:30. We have a 24-hour presence on the ship, as you can imagine. Just because you go to bed doesn't mean that we stop needing to maintain the vessel and have watch keepers and other people monitoring other areas and technical spaces of the ship. So we have marine technicians. Juliana is working the night shift here on this expedition. Probably heard her on the ascent yesterday. And then the ROV team will come on at 4:30 in the morning. They'll prep the vehicle. Scientists come a little bit later after that with anything that they need to fix onto the vehicle. And we aim to launch and be off deck at 6:30 Costa Rica time, or Central time here in North America. And then about 2 hours of descent. So you folks have probably been noticing that we're starting at about the same time every day. If there's anything that comes up, just to verify that we're good to go and double checking any of our systems before we launch. And then we are off bottom at about 4:30 local time, back on deck at 6:30. And then another 2 ROV pilots and technicians stick around after the dive to do post-dive operations checks, remove things from the vehicle, or do any new installations, troubleshooting, while the scientists are doing all of the sample processing. And then all of the other various systems on board have routine maintenance that we must do. We have a flow-through system for surface seawater measurements. The engineers are always working. The bridge and deck team also always working. The interior team, once they're done making our dinner and everything's been cleaned up, luckily they have a bit of a break. They don't need to be working until 3 in the morning. But yeah, there's always somebody sleeping on the ship, whether it's in the middle of the day or the middle of the night. So we always try to close doors quietly and keep our conversations to actual rooms and spaces instead of hallways. In the middle of the screen there, you saw some drop weights from a previous expedition. Those are sacrificial weights for either a lander or AUVs or any other vehicles that when your weight and your buoyancy is set for a lander, which is essentially just a platform that you can send certain items down to the seafloor or recover them. So we have a lander on board Falcor 2, but we are using it on this expedition. It has a large syntactic foam block at the top, and then a structure with a platform that we can load up with a bunch of cargo, and then it will have sacrificial weights. We can trigger that with an acoustic beacon, or if Sebastian's down in the neighborhood, then you can cruise on over and pull the release pin, and when the weight is released, then it becomes positively buoyant and returns back to the surface where we collect it and bring it back to the ship. In the past few times, we have used the lander with Sebastian, and when we trigger the lander and it starts ascending into the surface, Sebastian picks up the sacrificial weight and brings it back so we can use it again and limit the amount of impact that we have down on the seafloor. Notice what's for lunch today?
I did earlier, but I forgot. I did not know what's for dinner.
What's for dinner?
Sunday.
Steak. Sunday roast.
Roast, yeah. think it's
Some Yorkshire pudding.
it's Sunday roast. I
really?
think maybe some salmon as well.
Ooh.
Yeah.
So might be a light lunch in anticipation of a big dinner.
Yeah.
Ice cream day today too.
But we drift in the evening to reduce the impact of. Oh, there's a shackle off in the corner there.
Yeah.
Yeah,
We
to-
noticed that earlier. It was like
Yeah, we try to limit fuel consumption as much as possible. So anything we can do to be as efficient as possible on this vessel. You can see the shackle there with a line.
there's one more up there. I don't know if we'll be able to see it.
Yeah, it's caught up in the rifty, isn't it?
Yeah.
Yeah, so we've been returning to the same site most every day of this expedition so far. So we have seen a lot of these, but it's because this is a very active area of the East Pacific Rise. Many other expeditions have come here before us. So there are markers that people have put down for other experiments and the drop weights, the sacrificial drop weights that I was speaking about, but very quietly apparently because I had my mic all the way down. So you probably heard me on the other side of the room. But essentially the sacrificial weights are for when if something is deployed and then the weight makes it negatively buoyant, so it's affixed to this to the seabed, and then we want to have it come back up, we can use an acoustic trigger, and that will release the sacrificial weight, and it then becomes positively buoyant, and we can recover it at the surface. And then, is that the dye box from yesterday, or the?
This would be yesterday's.
That's yesterday's dye box, yeah. So if anyone remembers what the dye box looked like when it was getting the red dye pumped in, the non-toxic biodegradable red dye, I might add.
Fish love it.
Yeah, it looked a lot, it was much darker. But you can see here the design of this box is that it has the mesh that seawater can pass through, but that organisms are contained, and if they are going to emerge when we remove the box, if we see anything that isn't dyed red, then that means that they came up through the substrate. And that's just kind of a very basic overview of the concept, but if Sabina, if you wanted to elaborate on that or expand, please feel free. I don't want to
Yeah, sure.
take away
So-
from that. Yeah.
Yeah. So you can see one of the mesh boxes that we deployed yesterday. So the reason why we do this experiment is that we want to find out if animals can colonize vents via the subsurface conduits. And for this we basically choose an area that's rather flat so we can place our experiments, measure the temperature to get to know the environmental conditions. And then we basically put this mesh box on top of this place, and then afterwards we put a staining box on it and release the dye into it that stains all the alive animals. And then we leave the box down there for 10 days about, and afterwards we will go back to the site and collect the animals from the subsurface, and the ones that were stained have a red color. These were the ones that we already had settled before, but those that are not stained would be those that had arrived in the box from the subsurface.
Very cool. Thank you for that. We just have up in the top left corner the bag that we are filling with that vent fluid. So you can see the pump was indeed on. We're just a little impatient.
Never. The cool though about that is not that we have the angle for it. But I don't think we have the angle to see it.
Are you looking in person?
There's something other side of That's Riftia. That's really
The
cool to
spire.
look at.
Yeah.
The spire of it, but we just can't see it from the angle.
Yeah, yeah.
It has higher temperatures and has PPA worms on it very likely. But I think we cannot reach it with the camera. Can't see it yet.
Got it up on the screen now, but it's just in the one of our HD cameras, the static cameras.
So here you can see some typical mussel communities with the Bathmodeolus mussel, and you can also see some catalyze around. And when we zoom in a bit, you can also see that the mussels basically form an own habitat. There's also very rich with that offers habitat also for smaller organisms, like the snails you can see here. And if you would take this sample and like sieve it and then look at it under the microscope, you would not only see like the larger animals, but also a lot of small little critters, like copepods, small crustaceans, small worms, nematodes, and all these kinds of things. And on average, we find here about 50 species that live in such a mussel clump. Half of it is myofauna, so animals that are smaller than 1 millimeter, and the other half of it would be considered as macrofauna, animals that are larger than 1 millimeter in size. So basically we only see the tip of the iceberg when we watch with the video.
Look at all these things here.
We have Sabelid polychaetes, which live more in the peripheral areas. And that, this vent side here, you can also see very nice the zonation. So what basically the megafauna that we see here, so the tube worms, the mussels, they're also adapted to different temperature regimes. So the tube worms would always be like at the warmer places, and the mussels at the more cooler intermediate places. And the Sabelids that we have right now in the picture, they really live in the periphery and not directly in the vent fluids. They basically profit here in this area from the enriched organic material that is produced at the active vent itself.
And what kind of mussels are these? What species?
So this is Bathmodeolus thermophilus that you can see here. And it's these Bathmodeolus mussels you also find at other vent fields, for example, also in the Mid-Atlantic Ridge, but also in Indian Ocean. But we have like different species in the different biogeographic regions. But the mussels are very successful when you consider like where they are distributed globally at the hydrothermal vents.
Yeah, so quite a bit different than ones you'd order in a restaurant.
Yes, I wouldn't like to eat those. And it's also special because they have like, Riftia is kind of one type of symbiont, and Bathmodeolus has two types of symbionts and can also feed in addition.
Speaking of eating, we're going to have a pilot swap here.
Just fell on the bag. I've noted a few things on the back of that sheet just in case we need to look at it. Right.
So Chris and Russ are going to be heading up to get a bite to eat, and Zach and Carl Hill coming in. A little bit of seat adjustment. Everyone has their own preferences. If you guys are hearing the clicking and clacking going on in the control room here. Oh. And Zach's getting his daily caffeine fix.
It's not a beer.
No.
I'm going to keep reading. It's nice handwriting. I just can't
To check on deck ROV, God, HD, car in and out, boss God, was it? What are we doing?
Waiting,
Pumping?
yeah, 30 more minutes,
30 more minutes?
13.
13, okay. Can we look around? Can we all look around? A nice colony right there. So we're real close to that other experiment, huh?
Yes, they're all in an area of, I guess, like 10 by 10 meters, not even, something like that.
And this is where we're going to do spot 3? Right here?
Yes.
Ooh, this is cool. Did we already fire any Niskins or do we want to?
No, we didn't fire any Niskins so far. Wow, it's a huge cave. Oh, God.
Oh, look at that guy.
Yeah.
Polychaete?
No, the cake.
Sorry?
What is really huge is the cake that they prepare for.
Oh, it's
Yvonne's
Yvonne's birthday today.
Yeah.
I'm trying to do a panel. What is that?
Is that a tiny one? What is that?
What are you looking in the crack?
Yeah, little crack right there.
Eagle eye over here.
Huh. Thought that was an octopus for a second.
Oh.
The crack could be a brittle star, right?
Where are you looking at the moment?
That's
That's
in
a
the
small, yeah.
It's a little crab,
That's
huh?
a small crab, yeah. You can see the maxillipedes moving.
That's for when we go up, because it is Yvonne Rodriguez's birthday. Many of you would have heard her on a few of the streams. She's one of the scientists on board who comes from Costa Rica. So because we departed from Costa Rica, and we've been working in these waters the past, some of the previous expeditions, and they've been so great to us. We wanted to make sure that Yvonne could do some narration in Espanol for anyone who's tuning in from there. So she will be coming in later today, so be sure to wish her a happy birthday when she comes on. Hopefully there's some cake left over by the time we get up there.
It's cool. Each one of these have that little ball at the end with something different. It's their flair.
Yeah. Has anyone talked about what that is? 'Cause I have no idea.
There's just so much of this warm vent fluid everywhere. I mean, it's everywhere you look here.
Yeah, so here the water would not be warm. It's already cold, but you can see that all the particles in the water, these are the bacteria that are basically produced at the vent itself. And these guys, they profit from this primary production.
So basically the steps are go to a vent and then profit.
Yes.
Just doing a little panorama real quick. Trying to do one of these
Polynoid.
every day.
Scaly one. Some snails, another one.
Normally I try to not do this in autofocus, Carl, but because it's such a zoom, I think most of it would be autofocus if I did that. So I'm just going to do it in autofocus and see what happens. but I gotta wait every time and then let it focus, you know?
Yeah, it's also really hard with that shimmering water to really
Yeah.
crisp
Passing by,
images
yeah.
anyway.
It is, but it'll be a lot crisper than a single frame after this.
Yeah. Well, that's the thing. If anyone was listening yesterday, and we were kind of doing the dye box and filling a little bit of the time, and we were talking about the USBL system for the positioning. So you can see even the light that's traveling through the different temperature of the water, the shimmering and everything. Like if you see the pavement on a hot summer day, the same thing is happening with the sound that's traveling through the water, the acoustic signal that we use for the positioning. So right now we're sat down, we haven't moved, but obviously there's a lot of movement within the water in different depths and stratification. So our position is jumping around a little bit because this hot vent fluid that comes up really throws it off. The hotter the water is, the faster the sound travels through it, and then there are different concentrations of any of salt or conductive materials that are in there. But yeah, essentially it's the temperature change. So we're sitting still, but our position is jumping around a couple meters, so nothing too crazy, but much in the same way that we get the shimmer and difficulty trying to focus on these things.
What are these called again?
It's polyheats, sessile polyheats, sublida.
Sublita?
Mm-hmm.
Sublita.
Do you know what the little, each one of them has a little?
Yeah, I don't know.
You don't know?
Yeah.
No.
It's like they're, what's that thing? Skip it?
Oh.
My niece has one of those.
Oh, I forgot about those, man.
Shout out to Veda Saunders.
That's about 10 years ago, 20 years ago. Wasn't it?
Ja, am besten irgendwie so, dass viele Partikel drin sind.
Your kids don't have those set?
No.
Da, wo es Wasserfall ist.
I should get them
Dann
on
machen wir
that.
es nicht hier, jetzt nur woanders.
They look pretty fun.
Bei den Familientour.
Imagine trying to
Genau, einfach
sell
so
that
gute
idea
Stelle
at
mit
this
Wänden
day and
einfach
age.
so.
Oh, you
I
just
want to
make
make a toy that you strap to your kid's leg, and he flings it around at the other leg.
Yeah.
It'll be great.
Well, you attach it to an app, and you can gamify it, and then boom.
Yeah.
How many steps can you get in? How many skip-its can you get in?
Yeah, you have to have an app these days. Virtual reality. Quite pretty, these things.
Yeah, they are.
Oh, Gino available. Should grab one and sequence.
Yeah, we'll just do a quick check-in on the bag and see how we're doing here. Hey, there we go.
4 more
Starting to fill up.
minutes.
4 minutes. Oh wait, Zach, there was one that was coming back out there. Yeah, yeah.
So I guess these guys will hide if they see any disturbance like the larger worms, huh? That's their whole plan of survival, is they hide in those white tubes.
Yeah, it's like also when you look at polyheats, the different types you have. Sedentary polyheats, they build tubes and live inside, and you also have mobile polyheats, like the one that you can see here.
Yeah.
So this is a scale worm.
Scale worm, huh?
Yeah.
And what's he? Is he a predator, or we don't really know?
We don't really know. I would. Many of these are also detritus feeders, so they basically catch whatever they can.
Okay.
Look at that guy. That guy's different.
Which guy?
But the difference is that these scale worms, they kind of actively have to
Oh,
put
right
like.
in the middle there?
Yeah.
Oh, yeah.
Oh yeah, those are like hydroids almost, huh?
Mhm.
Let's look at these tube worms too, because I think we got a pretty good, maybe y'all already did, but we got a pretty good angle on them here. Very close. Give it a nice detailed shot of them feeding here. You know what they remind me of is flamingos.
Flamingos.
think we can get ready slowly.
Get ready, so.
Today's the 9th. Hold on, I'm gonna.
Alright.
Alright, here we go. Zooming out, rocking in. And
You're far too fast. We have to wait another 2 minutes.
sorry. I had to be fast, Carl's coming in like a Tyson blow to the dome there.
And Sabine, what are the little guys that are flying around that we can see in the light now?
These are, I cannot really see it good, but I would assume it's amphipods, Ventiella sulphuris. These are the amphipods that are very common here, and they often hang out around the tube bombs also. And you cannot really get them on focus here.
Trying, they
So-
might be a bit too close.
I think they're actually further behind the line, I think.
Yeah.
Yeah.
So maybe focus. Oh, there you go. Yeah.
And then down again, I think.
Yes, this is Ventiella sulphuris, an amphipod that occurs in really high abundances at this hydrothermal vents in East Pacific ice.
Amphipods.
All right, trusted viewers, it's almost the top of the hour, so we'll just do another quick station ID. You are watching live footage from ROV Sebastian, deployed from research vessel Falcor 2 of the Schmidt Ocean Institute, and we are here in the East Pacific Rise. And I'm going to go and grab some lunch and hand you off to Tyler.
Timing, good timing.
So your alarm?
Yes.
If
If you could.
want to grab one of these satellites, do you think it's easy to collect one? One of these satellites, you know? Yes. All those white ones.
You have to get that with the rock.
Okay. Just to put them in RNA later, maybe we could sequence them one day. There's no satellite genomes around.
That's Tica.
Okay.
That would be, if you could one day, just like that, so I can.
It might come up.
That'd be cool.
I asked Clarissa where she wants to take the Deniskins, but not like a lot of particles, so probably not here, but somewhere else, when we fly over somewhere.
Are we okay to leave it
Or we can also, I don't know.
to bag, or do you want to move that bottom handle too?
No, that's good.
It's good?
Yeah.
Otherwise, you would get rid of the water if you put it towards the direction.
Oh, let's not do that then.
And then you have to in case the handles move.
Stays good like this, no? The sample to keep it basalt, towards basalt, it's good, no? After you switch it off.
It's fine like that.
Yes.
Yeah.
That is the rule.
Okay, no problem.
No, only solutions.
Oh, yes.
Okay.
When you get time, you will see this.
Okay. So we have this sample now, no?
Yeah.
Okay, good. Temperature, this water sample, we can store this away.
Sure.
You wanna look at the wand?
Yeah.
Yes. You wanna see the tip here?
Yeah. Okay.
Alright, let me focus.
He's saying he puts his hair, but it is 3 hairs, or 4 or 5 maybe. Yeah.
Tomorrow more?
No, is he good? High tech. Okay. Great.
Thank you.
So this we did.
Roger that.
Roger that. Okay.
I need 2 quarts out to be able to get to.
You sure you don't wanna try and do it? Or is it close?
Yeah. Sounds like a bad idea.
Okay.
So I have 2 already.
Okay, that's probably good. I'm on that side over there.
Awesome. This.
So we've finished pumping seawater into the bag to bring back to Falcor 2 for the scientists to take a look at. And the pilots are going to stow that wand, which in an earlier shot you saw the low-tech but effective flow meter type situation we had there with the hairs on the end. And we just popped a shot of our now full bag of seawater that holds about 55 liters, I believe the scientist said. So we're finishing this part of the dive and gonna move on to the next part. We've got Dr. Monica Bright, principal investigator, is on the science mic. Zach's our pilot. We're doing some lunch changes here. Chill co-pilot, and this is Tyler on the other mic.
The 2 worms that are behind the frame, I think we need to remove the frame, you know, put it aside a little bit, because take a picture. We have a picture. Where's Andre?
Oh, sorry.
Can you print out a picture of where the frame is right now, because we have to remove it, and then
I mean, yes.
we have to remove it to collect some of the tube worms there and some of the mussels there. And
So you want to take me a picture now?
no, we have already one, no, with the frame, a good picture of this with the frame.
Yes, Sabine printed.
Can you print for me, because I don't have one and I
Yes.
need to collect now.
Yeah.
Before we basically start to collect. So we know that we put it back. Yeah, we have we will have a picture then to see where it is. We just put it aside. Not necessarily on the next tube-worm clump, because we will collect this also. Sensitive animals. Yeah, this is good place here, yeah. Okay.
Just one sample.
So we had more luck actually to sample with the other arm, because these soft parts, they make the tube worms slip out. So it's easier when you not collect with this one. And I want, I would like to do it that you touched, also I'm zooming in, okay. First I tell you which ones.
Well, I'll tell you this, if we can try it with the starboard, it'd be great, because with the port arm, it still has that issue where it might lose comms, and if it does, it'll do this.
You mean this one is better now, the one we see now?
'Cause
Okay.
if it loses comms, it'll do this.
Okay,
Boom, and punch them, you know?
okay,
But we can try it if this doesn't work.
okay. So the ones, those are the ones that stick out of the frame. So this below and this here.
Okay, those three?
Yeah, and the easiest, not necessarily to, one, if we kill them all is also fine, but maybe we manage not to kill them. So if you tip on this and then you grab,
Yep. And then pull up.
right, we
And
can
this-
try it.
And this is,
But I'd like to start with that top one first.
The top is good, yeah, this one
Yeah.
and this is going in a buy box?
goes in Biobox 4, but this is this not, is also sticking out, no? The plume.
Well,
I
that
don't know,
guy's-
sorry.
that guy's retracted.
Okay, that has retracted, so maybe we try to pull this. This is a good position, I'm thinking. Yeah.
And he's not got it in the rubbery part either, he's got it in the metal part, so
Yeah, we were having better success doing that.
it's pretty good.
See, this,
The problem is the thing's just embedded in the crack.
They're pretty good, are they?
yeah, but yeah, this might be a good idea. I don't know. Yeah, maybe better like this.
It's just slipping. Try again. Maybe if you rubber.
If you rotate more, will it just break it, or will it just give?
Yeah, I mean,
Slides, I'll
if
try
it,
again.
if difficult to say. The deeper you go, the
That looked like a safe grab there.
yeah, it's like yeah. Okay, this will not come out like this. Okay, then you just try to grab it from below and we kill it. So we try to grab it because it's in the way of the.
That when he let it go, though, it didn't flop over. It's kind of sticking up. I don't know if that makes a difference or not, but
I think, yeah, but I think
it's gonna flop.
if he has not enough strength to pull it from this side, then
I'm not
yeah.
gonna grab it. I just want to tip it so I can try and figure out where the best way to grab this. If I can even pull it to my side, maybe that'll help me.
Yeah.
So the method Chill is employing here is to get the tube worm alive.
This is
If you touch it, the plume
so it
retracts
doesn't
into the tube. And they're attempting to grab the top of the tube that does not have the tube worm in it
Others,
and pull it out from there
Yeah,
to preserve
this
the
is good.
specimen.
because then
But as you
you
can
might
see,
as
this
well
is a
take it as there is.
challenge, this particular animal, because it's hard to get a grip on it and it is rooted pretty well in that crack.
She said, okay, just grab as low as we can.
Yeah.
I'm just trying to
Then
isolate
to
it.
out. Sandra, we make a sampling.
Sample 39.
39 in the tube worm clump of experiment 3 because we need to remove some, they're too large. If it doesn't come out, then it doesn't come out. Then you just grab it and take the upper part and we put it in the box.
You know, I almost wonder if, because I got it up now, would it interfere with the box? That's the whole reason we're moving is because it blocked the box, right? And now
No,
it's
this.
not blocking.
Oh, you got it. You got it. All right, I'm wrapping in. Portion out whenever you're ready. Or can you just get in there? You need me to porch out?
Put it in the back box 4.
So I'll have to pop that bungee for you about.
Or it can be also in the box 3 has also nothing in it. No, do it in the 4 because we had some deployments in here. Sorry.
Okay. Let me,
What wheel works, Monica?
4.
What side are we?
So with the sample in the starboard arm, pilots can use the port arm to pull a bungee off of that bio box, so we can stow that tube worm in the proper place that scientists would like.
and you go down, right?
Down.
Should I annotate that this lead?
Yeah, but don't press the button because we will collect more. Just make it the note that one is, so we will write in the end how many are in there, okay?
I already created some.
Yeah, but don't press the button.
So you got the 2 camera views up here to see what the pilots are looking at. So oftentimes when you have to handle things on the front of the porch, it's tough to get a good view. So oftentimes when they're stowing the suction sampler, or like the pump wand that was out earlier, or high temp probe, if those are on the front of the porch, it's a little bit more challenging to stow those devices than you would think.
We are finished and then we can write whole amount. So write 1, 2, 1 hour and then wait for the notes to press.
So we're gonna put another one in here, right?
Yeah, we put much more in here.
I'll leave it open.
Mm-hmm. Let me see. The bleeding guy. Oh yeah. So those 2.
Not going inside.
Yeah, grab it from the bottom, and you can also grab just, I mean, if you can. So this is not in the way we want to collect both 2. So. Yeah, good.
Oh.
Yeah.
We just keep going, huh?
You just keep going. There's no possibility that, yeah, no possibility other than this. Yeah, this. This is 39, no?
39.
Okay.
Sample 39.
Okay.
Hold on.
Okay. Can I see it from the top? Can I have a top view?
Of the
Yeah.
box?
Yeah.
Sure.
Also of the area.
This is your best top view. 'Cause that's
This is the best
camera.
view. Okay.
Zoom in a bit for you.
Mm-hmm. Okay. Maybe we remove this one here. I mean the muscle, if you
Muscle
can.
all the way to the right.
Mm-hmm. Can you? Yeah, you just notice it, but can you look if the printout is here? Okay.
Look at the little brittle stone.
Mm. Ouais. Cool, good. This is alive. Okay.
Did we try the rock breaker yet?
Hmm?
Did we try the rock breaker yet?
No, I want to try it.
Huh?
Okay. Can we try to put the frame now?
Sure.
Here. This one I think we will correct this also, but we can then shift a little bit. just want to see. There's no printout. Can you go into the dive and look for the experimental site highlight pictures where you can see basically.
So after taking those samples and cleaning the experimental site up a little bit, we're going to set the frame back down and see how it's looking for tomorrow's experiment.
We had like 28, 20, I don't know. I have to look up the temperature. 23 degrees it was.
I wonder if it's gonna get pretty hot inside that mesh
Yeah,
box.
but I don't know.
Like a little sauna, you know?
Yeah. Okay. That would
Can I make a
fit.
suggestion?
Yes.
Yesterday when we placed the mesh box,
Yeah.
it blocks a lot of our view, so it's very difficult to see how far away or close, like, you know what I mean? So what if we took, do I have a pointer somewhere?
Here.
If we put maybe a muscle here, pointing at this corner, and a muscle here, far enough so it does not interfere with the box, but it would just mark these two corners.
Mm-hmm.
We would then see how far away from those 2 points to put the box. We're just so blind on the other side of the box, it's hard.
You have to find a good marker in the front. That's what I mean.
Yeah,
To place it
if
again
could
like we had it.
Somehow mark these 2 corners that we
Yeah,
can't
well,
see,
I
then
cut
we would know that the placement of the
immediately.
back side of the box is
Okay.
correct. But I don't know what you would want to use to mark that,
The
or,
muscles maybe not good. They can move.
sure, okay.
Also, if they are good in health, they could move.
What
So
if we did like a loose rock? Because as you can see, there's no loose rocks here. So if we had 2 loose rocks, they would stand out, I think. Or really, honestly, anything.
yeah, something, yeah,
Anything that you think is a good.
yeah.
So if you couldn't pick up that conversation, Chill, one of the pilots, is suggesting that we set something down the seafloor to help mark where that frame is right now. So when they deploy the box tomorrow, it will be easier for the pilots to visually line themselves. So if the front's lined up, the assumption is the back will be in the correct place as well.
Flat with this frame now.
She's wanting to fly to the other side of that.
I mean,
Try some other areas.
so kind of to, yeah.
Remember that science experiments to your right.
Yeah, let me just check
Or
on
maybe, can you take
So
the
you're
frame grab and can you print it and can you find the frame grab for printing?
Way would be go to your left and turn right.
Salva,
Go to my left and turn right.
I don't see any
I'll face
effect
south.
highlight frame grab for the experiment.
So that discussion about
Settings changed since we got it.
setting things down to mark the frame place is indicative of the troubleshooting that goes into doing these deep sea dives and experiments. So constantly tweaking to find the best way to deploy these experiments, the most successful way. And again, this is the first time this particular experiment has been deployed on the deep sea. So they've done 2, but those are the first 2 times it's been deployed in the deep sea. So the team is finding their way through the best way to do this experiment, because there's a lot of delicate parts to it, and there are some challenges if you've seen the deployments prior. So it's constant problem solving, constant troubleshooting, constant communication between the scientists and the pilots to find the best way to make the most successful experiment possible.
Can you not search for it with highlight here, Victor?
Alright, so now we're good to go.
The only
So I'm right now. Everything's shut.
frame grab, science frame grab is this one, and this is what you see in the science frame grab. This is the only upgrade tool. There's another frame grab here, and this is how it looks. That upgrade tool also. There's another one here.
I think the frame would probably work too, huh?
When
There's a comment.
it's around on pump.
Scratching it with a crowbar, it's actually not a bad idea.
Yeah.
Just scratch some lines and
I can,
do have
I
one.
can go in the video.
For free.
Find you.
Yeah, like that.
that's strange.
What is this here? Observation salver. This is here what this guy is.
Where's that other?
I got brought
do underneath you now.
I brought this here because there are already three people in my road for.
Yeah, but I need to go to the earlier. Is the earlier up or down? Down.
Down, the earlier is down.
So highlight frame rate is nothing.
There's only one
I don't
highlight
think
frame rate from Andre. It appearing in my screen. You want me to look in the video? I can find you in the video.
What is this then?
That's like my safe heading
I did not do that.
Okay.
You want me to reset?
Should I bring Andre?
Yeah.
Actually,
I bring Andre.
Ask him if he's outside, then he can
He's sitting, but I think
also.
this is not updating.
I bring him.
Wait, now it is.
Yeah.
It's just real slow.
Because it was that strange. Okay, I just reset it.
Alright, so I'm gonna be sitting on some muscles over here, is that alright? Or am I just looking, or are we sitting down? Over here, Monica?
Are you talking to me?
Yeah, you want me to sit down, or you just want to go?
Sit down. I want to look at the entire frame with a close up to see if there are holes or if we would have to.
So I could be wrong there, but I think this is down. So if you put your ram out somewhere here, I think you won't actually be sitting on it.
Okay. I just don't want to get anywhere near this other experiment box, you know?
Right.
That would be a bummer.
I think.
Can I brace against these worms with one of my?
If possible, not, because there's a deployment here of other people.
Alright, well I can look at it then, but I don't know if I should
Yeah,
sit down. What's the other side might be
Do
there.
your camera for you, Zach?
I can look at it
The
like
other
this
side
also.
might be better for sitting down, I think.
I think this looks good. Ah, sorry.
The camera view we got here is
This is pretty
a
flat.
good look at the tight quarters the pilots are working with. So one of our own experiments is there on the top left corner. A clump of tube worms that we're also trying to avoid is in the top right corner. And so right now, the team is examining the frame, double checking everything, trying to make sure this is going to be a great site for the deployment of the experiment tomorrow.
Better would be for the box also. We have to collect a comparative sample. So with this one here, we could collect this, then it's also not in the way for the deployment because the plumes reach out here.
Sure, I'm gonna
So-
go back to where I can sit
Yeah.
down.
Right, you can set down where it was before also. Salva, can you sit down and then
Monica, what we were talking about earlier about trying to mark these corners.
Yeah.
There was a comment about using the bar and just scratching the rock to make mark.
let's see it. I rather look at the shape of the serpolites. That's how we find it also, because if you take a picture, a good one from the top,
We did that last time, and when we did the vacuum, the shapes of those changed, and we lost sight of.
Yeah,
where it was.
we,
We
I
had to
think,
reposition it twice.
yeah. I think we will vacuum just not scraping anything, but just go over it on the top for the small parts or so, because the scraping is not so good really. So now you can take a highlight picture of the frame, Salva.
Yes. You want to print it out?
No, I have to get closer. We will do it in the end again. Okay? Before we leave, we will do it.
So Monica, when you said you wanted to collect those samples for comparison, what exactly do you mean? What are you going to compare them against?
Can you repeat, please?
Yeah. So you said you want to collect those 2 tube worms in the back as a comparison?
Yeah, we need, because we leave the community more or less intact. We took some large ones out, but we keep it intact, and we will collect it after our experiment, after the dyeing. We take also, for comparison, some of the community in the surrounding here.
Cool. Thank you.
So, I don't know if this is too far away, but if we could try to collect this here. Maybe this one is, I don't know. Well, see, you can try at least that maybe you get them out alive, but if not, then yeah, now it's gone, I think, but
He printed it out that for you. He's looking for where that.
but we took a picture when the frame was in.
I'm printing all the trim grabs that we took. I will bring you.
This is good. Take it all. That's what we want. Yeah, yeah. Firebox 4. Oh, now I have to. Okay, that's good.
So we got the porch coming out to put that collection in a bio box. It was a good collection because Jill was able to pull the whole tube worm out from the tube. So it should be intact and alive.
It's the same picture twice.
Yeah,
Almost.
I did many.
But this is like this and this, no?
Yeah, these are a little.
This is the same.
Yeah.
Or same, I
This
don't
is a little bit something.
This is this.
Yeah.
Okay.
But this is wrong or?
No. Yeah, I thought it there might be more from the top.
Okay.
So this is basically the number of the tube worms and what we collected from the riverside is 3 tube worms and 1 mussel. And then you say close by, nearby or next community and we throw it in the same bio box for. So basically this is the observation you should keep
Okay, I close it already. But
So now since part of that sample fell into experimental site, Jill's going to clean that up.
Doesn't matter. If I said, please can you leave open when I tell you you
And
have
that
to leave
first
it open?
grab of the tube worm may have just been the tube and not the worm itself.
I will do it. This so nearby community.
What is in the previous description of Salva?
If I have to look, I have to close this. I close it. I close the comment. But I can tell you the sample of sample 39 says experiment 3.
What does it say?
In the tube clamp of experiment 3 because
So here's some of the scientists talking in the background. They're discussing
there is an observation that says so far
observations of data that's been logged. So throughout the course of a dive, the scientists will, using computer system we have on board here, log observations, take screen captures. So they're tracking every minute of this dive, so they have contextual data. They can refer to the video. It also helps them refer to the samples. But they're taking screen grabs as well. So when we get to these sites where the placement of the experiment is crucial, they can refer back to the previous day's dives, look at screen caps of where the frame was set, what it looks like, what's around. So using all this information to ensure that the experiment is successful.
3 foot worms, 1 mussel were taken out from the experimental site. Number 3, inside the frame. Plus near site community plus near site community also put in all in Firebox 4 and don't close it.
Okay. Should I write one more muscle in the comment?
No.
Should take more of this here. If they're dead, doesn't matter, we should just collect them because otherwise it might attract a lot of, I don't know.
as the camera's following the manipulator as it's making the samples. When you get a view of the landscape, you can see there's quite a bit of life down here. So as Dr. Sabina Gallner was explaining yesterday, in these areas there's a very high density of life. Maybe not diversity, but there's a lot of life surrounding this small area where these vents are. And you can see when we pull out here on the camera, there's a lot of mussels, tube worms. It's a carpet of life down here on the seafloor where these vents are. And there's shrimp.
Maybe you can try to scoop in here for the mussels.
Like the observation is open. You still want it open?
Yeah, because we will scoop for the mussels also. We just to make it larger, yeah. It's just the vicinity, I want to collect more.
Okay.
So depending on the dive plan, ROV Sebastian will be set up with a number of tools. I anticipate scientists need here on the seafloor. So one of those tools is this metal scoop. And Shill's going to use it to try to sample some mussels that were close to that experimental site.
Goes also in the same bio box.
And
That's
there we
good.
just had a nice shot of tube worms attracting their plumes back into the tube. Pretty sensitive. So oftentimes you'll see the manipulator touch the seafloor or bump one of them, and that red plume retracts back in.
I don't know if this, we should collect this one, maybe this one over there. So they're out of the, this could be also collected, but I don't know if it's easier with the scoop or with the individually. Or maybe this is just part of a shell here. If you think it's easier to grab it, it's also, you can also grab it, but I don't know what is easier. Both is difficult. Hmm.
So on your screen right now, we've got another example of how the pilots have to use multiple camera angles in order to make collections sometimes. So on our razor sharp 4K camera, that mussel is obscured by a clump of tube worms. So Chill's also going to use the sit cam. That's our top-down view up there. Try to gauge where that mussel is and grab it. And there it is. And this one's a little bit easier to see.
That looks pretty good. Okay, I think this is enough from here. We will, you can put away that scoop and we will go over the area with the suction sample. So now you can close and just write them. You have the two ones on the side and the neighbor side just write live muscles and some dead tube worms. And then you make the next sample.
Back up some portion.
My box for this now.
Yeah.
Said some social samples next.
With the, I think first with the fine net, this is like 4, 5 or 6.
We are in 7 right now. Section sample jar 7. She want to find.
What batch would you like for this one?
The fine net is 1, 2, 3 as far as I know, and 4, 5, 6 is the large one, so we take the fine one.
So the team is just setting up for a suction sampler collection. So the suction sampler on ROV Sebastian, you'll see the pilots pull out a hose, for lack of a better term, turn on a pump, and we can suction sample things from the seafloor, sometimes a water column depending on the needs. But there's 8 canisters on ROV Sebastian, and the team has set up different levels of filters on those samplers, so they can get finer samples or more coarse samples depending on what the scientists need. So in preparation for experiment 3, the team is going to continue taking samples here, and you're seeing them remove the suction sampler from the front of the porch.
can go like here in this area, and then over the area you emptied over there, like all this. Like here, this is like what we emptied.
Yeah, you can always just torch out. We have enough hose, it's just the right.
Should be maybe not so much scrape over the rock, but stay a little bit more above. When if anything goes in, then so.
This is where you want to vacuum.
Yeah, right here. This area would be good. But I don't know if, yeah, like this, super.
What additional text do you want on that?
The suction sample with the fine net over the emptied area close by, experiment free.
So Monica, what specifically are you hoping to sample with the fine mesh suction sampler?
No, yeah, I mean, we keep with the fine net also smaller organism in the suction sampler, so if you go with a very coarse net, the very small animals or the small animals would just be, you know, out again because the net is very, very large. So this is basically a fine net, keeps more the small animals in also. The danger is that it clogs up very fast because it's fine, but we have been doing quite good with this net so far. So we try it again.
Excellent.
Huh?
That eelpout is challenging show for supremacy of the deep sea. Oh boy.
Ah!
He's a little rascal, isn't he?
Yeah, it's like you can go also over here a little bit because
So if you're just joining our live stream, here's a quick recap for you. So this is live footage from 2.5 kilometers below the surface of the Pacific Ocean. We're on the East Pacific Rise. And this footage is coming to you from ROV Sebastian, the remotely operated vehicle operated by the Schmidt Ocean Institute. It's deployed off of RV Falkor 2, our research vessel. So Sebastian is connected to Falkor 2 by a 6-kilometer long umbilical. And so that umbilical provides the vehicle with power and communication. So the pilots, when they operate the vehicle up here, they can instantaneously see what's happening on the seafloor because we are running fiber optic cables down to the vehicle for data. And so what we're doing right here is we are suction sampling close to an experiment site we're going to deploy tomorrow. And so the suction sampler is simply suctioning organisms, whatever the scientists want. And so this particular canister is outfitted with fine mesh, so scientists can get small organisms and bring them up for sampling. That frame you see in the bottom left-hand corner is going to be the site for an experiment we'll deploy tomorrow. It'll be our 3rd time deploying an experiment like this.
I was just pointing kind of over towards.
And if you see the top left of this screen is a previous deployment. So the scientists are putting down these boxes on the seafloor and adhering them to the seafloor. So it's got a tight fit on the seafloor. And so what happens is we'll deploy those boxes and then we'll pump some non-toxic dye into those boxes, wait a little while, stain everything, and then pump that dye back out. And so everything in that box is going to be stained a pretty vivid crimson red. And so what the scientists are looking to see is when we return to the site and remove those boxes, will there be new organisms on top of that dye? Will we see undyed creatures in that box? And if we do, that might signify that the larvae from tube worms, such as those creatures you're seeing on the screen there, the white tubes with the red plumes, may be traveling through the hydrothermal vents beneath the surface. So maybe doing some subsurface traveling to appear at different places and recolonize. So rather than swimming through the water column or moving through the water column, actually traveling through the underworld of hydrothermal vents, which is the name of this expedition. So eventually, sometimes the pilots have to give the suction sample a little shake to loosen debris or rocks or other things that may have been sucked in there. And Dr. Monica Bright, the principal investigator for this expedition, is on the science mic, and she's working with the pilots. We have Alex and Chill as a co-pilot on the manipulators right now. They're working together to get the best samples and prepare the site for tomorrow's experiment. And it looks like that may be the end of the suction sampling.
No, this is in the control where we cleared the area of control site 3. 3 would be in the frame salver, and outside is the control.
Okay.
I did not suction sample inside. Let me see what would be the next. Let me see what we have. Temperature things. Community, control, suction sample, fine net, control. We have this also. What I like to sample is a rock from this area, but I don't know if I should dare to throw this big thing next to our mesh box in our frame. Maybe we just try with the sizzle to go somewhere where we're collecting here and break off a piece of rock. So like we were here, from here somewhere.
If she wants to go here, we're gonna have to fly around.
All the way face of the direction.
Unless there's something underneath us. We can pick up and we can just take a quick look.
So just heads up. Go to the border. Not bad, just so good. It's just routing it. So,
Oh, yeah, I saw that.
alright, so I'm gonna just come up and take a look, and we might have to just go to the other side.
Okay, that would give us also a good possibility to take a view, as a frame, as a highlight frame, a picture from top, no? If you go high.
Should I highlight video of that?
Wait. Later. Now you can take.
Highlight.
Yeah, but if the frame has to be in it, okay? You did?
Yes.
Okay. Thanks.
Piece right there. Is this too far away? Looks like a piece about to break out right here. Excuse me. There's a piece right here.
Yeah, but this is this size.
No, right here. So, is it too far away?
No, you can try to get some of it. Or let me look what is inside, because if there's no flow then I cannot use it. Can I use the camera? No, I cannot use this. I need something with flow. Sorry. No, I cannot use this one.
So there, Dr. Bright was using the camera to check this area for flow, and that's hydrothermal flow, which at these vents we can tell because there's a shimmer to the water that's indicative of hydrothermal flow. So she says there's no flow there, so we'll look for a different place to sample.
Kind of, yeah. I mean, I don't know, can you sit down here and try to go in here a little bit, just for a little piece?
So on our sit cam here, you can see a drop off in the bottom right hand corner.
Yeah.
Pull up.
I mean, we can let it go also, because,
I just don't see what I'm gonna
yeah.
So we have a little bit of our topography up here on the screen as well.
I saw what I thought
But this
Imagery.
earlier. That is a little rock, I think, right there. It came out when we did the worms. I don't know if that's big enough for you.
Oh, if you have
That right here.
yeah, actually, yes. If that came up, and yeah, this would be good. Exactly this.
Yeah, that popped out when I did the worms.
Good. I didn't see this. Yes, we just, if you can grab this, that would be exactly from this place also. It's like from control side experiment 2.
So this is a sample of the one?
Yeah. is the next one, yeah. But just wait first before you lower it in, because sometimes it,
I don't want to slow it down, it's really hard to pick up when it's flat. If we grab that rock, are you going to want more rocks?
no, I take only this and we put it in the bio box 4.
Okay, so I put the chisel away. We're not
Yes,
gonna need it
yeah,
okay.
yeah.
So the team has identified a rock to sample. And they're going to grab that rock.
This is just write. What did you write? Did you write anything?
I didn't make anything yet. If you want me to make it, I can get
Yeah, we just say like the next numbers would be
41.
40. What is 39? What is 40?
40 is the section sample.
Ah, okay. Yeah, right. So 40, we make 41. One rock by a box.
So rather than having to use the chisel to pry a rock sample up,
By box 4, yeah.
the team's found a very handy to grab little chunk of rock here. Sample it with a lot less effort.
Okay.
So while the team decides on their next step, we'll take another look at that bathymetry. So this is some very high resolution bathymetry. I believe it's collected by AUV Century. But it gives you a good idea of the landscape that we could see with unlimited visibility. So it's quite a striking landscape here on the bottom of the specific ridge.
No problem. Good. I think this is a good picture. This we have good picture from above also, no? So we have a picture from above, right?
So that yellow box is ROV Sebastian. And that sort of bird's nest of line around it is our track. As you can see, this has been a pretty compact dive, been in the same area. But this does give you a good idea of the dynamic landscape we're operating in here.
Should do this, but this is here the corner whatever, and then basically this. And right here. Can you take another highlight frame grab?
So again, when the team is referring to a highlight frame grab,
Oh yeah.
in our logging system, the scientists can grab a frame so they can reference this later, and they will look at these pictures
I mean,
today and tomorrow.
I don't think it,
And they're, you can hear some scribbling, so they're referencing it, drawing pictures.
the distance between here and here is basically almost the same. It's just that we need to look for.
That's true, but you're able to see the inside of that frame right now. But when you do the box, you cannot see the inside.
this is
So you
true.
don't know that. That's why I highly recommend we mark the corners somehow.
On the other side,
Yes.
how would we mark it?
Just set something down.
I gave a couple options.
Yeah.
Set some down, or take the chisel and just scratch into the rock.
We can try this
And
from,
just-
but I think the other side is probably then the better one than this side, no?
Oh yeah, I agree.
Then we can try to do this. If it helps, good. If it doesn't help, it's the same as if you wouldn't have done it, but then we need to place it also, no?
There's no negatives. If I
Like
scratch
that's
the
one thing,
rock,
like you
yeah.
scratch it, if you see it, we will take a really close up. If you see it, good.
Yeah.
This is from this side, yeah. Great. Scrape. Another one's on the frame grab. Let's take another highlight frame grab. Can I use the camera?
Yeah, please.
Fast? Where the crack goes in here. This is where this, exactly where that is. I will mark this later.
You want to frame now?
Yeah, because I can see good.
So if you're just joining us, or if you're new to these deep sea dive streams, right in the middle of your screen there is the shimmer. So that is the hydrothermal flow coming out of this site. So that water is higher temperature, often rich with different minerals, and so it's got a distinctive shimmer to it. So earlier when Dr. Monica Bright was referencing and looking for a rock sample, she didn't see any shimmer. That is the shimmer. And so we can see the tube worms and mussels are gathered around that. And this is a little oasis of life here 2.5 kilometers down in the deep dark ocean.
But I have the areas where I want to, where we have to do this here.
Okay, I have this. Okay.
Pretty hot inside, no? It's like 20 degrees.
Here and here somewhere, no? That's what you meant. Okay. We go for it. We try it. Sure.
So what the team is doing now is this is our third time deploying these experiments. And so tomorrow the ROV Sebastian will come down to the seafloor, and the pilots will spread some adhesive caulking on the seafloor, and they will set down a series of 2 boxes. First box is a mesh box, you can see those in the background sometimes, and the second is a box that fit over that box. And so the scientists want a really precise placement of those boxes. That's why the frame is down there right now. But in setting those boxes down, it's hard for the pilots to get a visual reference of where exactly it should be, because the box itself obscures their vision of where it should be. So right now, the frame, you can see the inside, you can see the backside, you can see everything. But tomorrow morning, they'll have much less visibility in setting that box down. So they're going to try to figure out a way to mark the edges of that frame so they have a visual reference when they're putting that box down. So this is all in preparation for deployment of that experiment tomorrow. And so in discussing a few options of how best to mark this, the first attempt is going to be with our trusty chisel. See if we can scratch some marks in there. So here comes the port arm. So what the pilots are doing here is they're getting the best grip possible on this chisel. So even though the manipulators on Sebastian have quite a bit of articulation, it's still nothing like human hand or human arm. So one of the challenges is ensuring they've gripped the tool in the right place so they can make it do what they want. So a lot of forethought goes into even picking something up with one of Sebastian's manipulators. Because if it's at a bad angle or it's going to fall out of the manipulator, then you got to scrub what you're doing.
on this side here, we just put it a little bit further out than this one. If it's here tomorrow, we take a close up now. Here, you scraped here a little bit, right?
I tried, but I didn't really scrape it with the RVs. We're still trying to dial it in and
Yeah,
get it to work.
yeah.
I get the highlight.
Right, get a highlight.
ROV Bridge.
Go ahead, Bridge.
I'm just going to start bringing the headed round to port about 300, so about 40 degrees to port. I don't know if you want to move me south a little bit.
Yeah, copy that. I'll put in a move.
Cheers.
How's that look, Tony? You think that'll work?
Yeah, that should be fine, mate, I think.
Alright, thank you.
So if you pick that up, that was a bridge calling down to the control room. So they're going to swing the heading of Falkor 2 around a little bit, but it takes a bit of coordination because you want Sebastian in a proper place in relation
There's a little mark.
There's a
to
little
Falkor
mark
2.
here, okay. Scrape. Ah,
Ooh.
okay.
Wow, I didn't expect that.
This is this that goes outside here, see? And here.
Okay, well,
Okay.
it is 2 marks, so I guess better than.
Yeah, we will remember this one also. This is a shell of a mussel that's closer, and this is basically. Here we have a scrape. Okay, if we can zoom in again after you.
Alright, so we have our
put away the
2
scissor,
marks on the
then
seafloor
we take another.
to help the team line up the experiment tomorrow.
We zoom in more.
If you notice just there, the camera pushed out. So the side cam on Sebastian is on a rail, it can come in and out to protect it if we're moving the arms around.
Just right after scraping next to frame.
You want to print it now?
It's okay, I have it here also, and then, yeah, you can print it. You just take it.
Just send it to the camera and then
Yeah, this one here. This one here. Okay. Good, this was good. Great, thanks. I think I leave this rock throwing, this big metal piece throwing on the rock until tomorrow because we have to come back anyway. And I have to find a place that is further away because these plates, I said this is so close now to all experimental things that I don't want to try it here because we'll try this tomorrow. So the next goal would be to find small tube worm, a small tube worm clump kind of around the corner here where we have been collecting already. It's like, I think, where is it? If you fly over this sort of and go down, then we have to circle around again, you know, away from the other deployments, and we will just try to settle somewhere and look for a clump of small tube worms. Because mussels we have enough that are alive, so they can we can share this.
So we're done in this area. Occasionally you see experiments and deployments from previous expeditions, including weights that were dropped by submersibles or other experiments in general. So this is a pretty well explored area we're in right now.
Thank you. I think if you go
This one? They look maybe smaller?
this, no, this is difficult to call. Basically the first thing we did, no, almost the first. They're smaller, no? Maybe not enough, but they're smaller here.
Monica, I have mapped the problems. What do you need?
Den Raumleid. Yes. Containing.
Unless,
So basically, this here and this here. This is just to basically take this picture then, or take this information.
This is a really great shot of just the density of life we're seeing down here.
This is okay?
This will, also really, what
This is Brazil.
So, yeah.
So very good idea. This two are very good idea.
This is the same, so this is basically what we want.
I have.
No, this is not okay because we're not sitting down. No, actually we are. Okay, this is good because it says 3 meters.
So should I print it?
Yeah, because then they can log it in because we did not.
You want to print this I put.
That's just
This.
there in the Bible.
Okay?
Yeah, this.
This is.
we should be doing this in the bottom 3, so yeah.
When we go back and make a waypoint because let's just see here.
Honestly, do you want to not put these in then?
3.
Excuse, so because one of them's damaged, do you want to
Yeah.
not put these in the same box?
The damaged one is this one here.
Okay.
So far, I think the blood is coming out from here.
It
So
looks like the top one's good right there.
Yeah.
this is okay, I think, if you can get it in.
This is sample water.
This is the next sample in fava flow, so basically, yeah. Yeah. The one that, oh, this, yeah, this is good. This will take.
I got a rock.
Yes,
You don't want that, do you?
yes, we want this.
You do?
Uh-huh.
I totally meant to grab that rock.
A feat of incredible skill. Jill captured a rock that this scientist want.
I think now would be also possible just to, I think that this one is the bleeding one, but if we just grab here also, then you would get smaller here also, you know, without the, or with or without the scoop, I don't know. Ah, this is the bleeding one. This one is the bleeding one. This might be loose, this area. Oh, there's one for later.
What do you want me to create a sample water?
Right, tubums, muscles, rock, fava flow. I think if you grab maybe the muscle, something will come with it or something. Okay. Good. That goes in.
You saw a muscle, you said?
I thought if you, let me see. if you try to grab here, maybe something else comes. Or this one here, or also here on this one, I think small tube worms hang. Yeah, we take the rock. Who cares? There's several only small ones. This is very good.
So in a single sample, we've got a mussel, some small tube worms, and some rocks. A very efficient grab.
This is good. Great. There are small ones on it. More. If we find more. Let's see. Yeah. Here are small ones, no?
Yeah, maybe that mussel is going.
Yeah. I think this is also good. Yeah, this is a good one also.
So what happens down here in mission control when the scientist works with the ROV team to collect samples is, of course, there are screens all over this room. And in front of the scientist's chair, there's a big screen that has our SI camera. And the scientists have pointers, so they can point out on the screen what they'd like the pilots to grab. So as I mentioned before, it's constant communication back and forth, trying to figure out what to sample, the best way to sample it. Yeah, a lot of strategic communication here.
Let me see. There are many here, but I don't know where they hang. I don't know. This one, no, if you squeeze here, then it's all bleeding here. This is the bottom part, this is the top part. This is the top?
Yeah, I just barely grabbed the top now.
Ah, okay.
I watched the worm contract in there.
Ah, okay. Good.
That's a good collection. Often if you've been watching, it's very difficult to scare the plume down the tube, grab the tube, and pull the whole thing out, but that one looked deceptively easy.
I don't know if it's possible, but if you open your claw and you go below those small ones, I don't know. This is a whole thing like of small ones. Get them. is there's a rock here, yeah. But the turbines are
It's good. It's hard to like keep layers fall off.
this is yeah, and there's this bleeder. I mean this one. Ah, you cannot. It's a balance act. Oh, this is. I don't think that this is not possible. No, it's not possible. Okay. Let's look if we can see if they hang on a muscle or something.
Grab that tiny little guy right there. You agree that's
You mean this here?
the tip of him, a little tiny one right there.
Yeah. Hmm. Also two. Mm-hmm.
ROV bridge.
Great.
Go
Those
ahead,
are
Rich.
great.
Anyway, yeah, we're just seeing a bit of a shift in the DP current, so if it's okay for you, I'll just move a little bit more to the southeast, just so that I can continue bringing the heading round to port a bit more.
Yep, that sounds good. We'll update our waypoint when you do. Just if you could keep the range to the RV about the same. That sounds good. If you just keep the range to the RV about the same, that'd be great.
Yeah, no worries, man. Cheers.
I worm. Yeah, we go. We have enough muscles. You're going for the smallest. Ambitious.
He likes a challenge.
Come on. This one, here's the top of this one.
Oh, is it?
Yeah,
You're right.
of this one is here the top, but I think you could grab it good because it's retracted. don't know how many do we have. Oh. Good. Take.
All right.
That looks super. Waypoint. Just gonna look how long it took us to do some stuff. Okay,
If you're just joining us on the live stream, this is the Underworld of Hydrothermal Vents Expedition. So we have a science party here on Falcor 2, and we are down 2.5 kilometers beneath the surface of the Pacific Ocean on the East Pacific Rise. We're near the Tica vents area, so we're doing a lot of work on hydrothermal vents. And this is live footage from ROV Sebastian, a remotely controlled, remotely operated vehicle that is tethered to research vessel Falcor 2. So these are live images from the seafloor, and you are watching our team of ROV pilots. We have Alex as pilot. Chill is our co-pilot right now. He's working this starboard manipulator, and they are sampling tube worms. So these white tube-like objects with the red plumes. The science party wants to gather some samples of these. This is an organism that we are studying quite closely on this expedition. So today's dive was about preparing for a big experiment that's going to happen tomorrow and doing some sampling. That is Dr. Monica Bright, our principal investigator. She is on the scientist microphone, and this is Tyler. I'm currently sitting in the multimedia technician position, and I'm on this expedition as a marine tech.
Actually, there's some in here. Maybe can you put them, the rock and the two bombs, also in the box? Yeah.
Or maybe just trying to go below and have them roll inside. Because
To have them what?
They drop when they're disturbed. So if
Okay,
you go below,
yeah.
maybe they fall.
This is. There's almost no way to collect them. I have not much time, maybe 10 minutes or so.
Yeah.
First we need to show them, and then we need to think, because I think also that the suction sampler cannot take them, and the scoop is also very difficult. Okay. Let's see.
We're done with the scoop then?
We try with the scoop to get those snails. So,
Oh, I thought we were suction sampling.
yeah, actually let's try with the scoop first, because you have it in the hand, also in the arm.
The tube, this one could be.
Chama, I show you one in detail.
This is a cute one.
Okay.
There's one, and there's another. So if you could go with the.
Where's the?
There's one here.
Yeah, this is one, but here not. This is not one. You pointed here. There's nothing
Yeah,
here.
true.
This one.
Yes. I think below, on the bottom.
You have to come from below, because
I don't know which might be easier.
I
There's
scoop-
one
I-
here and there's one there.
This looks like we're going to try to sample perhaps a snail now. You can see a small snail on your screen. And so on Falcor 2, this live stream is shown throughout the ship, in the various labs, in the mess, all over the ship. So the scientists, even if they're not in mission control, can keep tabs on where we are and what we're doing. And occasionally, scientists will come in and see a sample they'd like. And so they're able to spot that from, say, the main lab. Instead of being in mission control, they can come in and request that.
What's the name of the catalyst?
Yeah, there are two here.
Just the other one that's falling down to the bottom.
This one.
That muscle.
Yeah. Bottom will be connected to let's see what it is.
Let's see. It's just below here. It sits here. Ah, there's another one here. Okay. Yeah.
This graph is not cooperating.
No. Okay, there's here now. See there, those two from below. So wait.
That was a good shot of the pilot adjusting his grip on the tool. We have another deep sea creature challenging chill for supremacy of the ocean.
It's a trend today. So far lost. Every time.
0 for 2 for chill today. The unbending nature of the deep sea.
One we have. Yeah, one is good. Put it in the call quiver 1 or 2 or wherever.
Let's just get a good view, make sure we got it where it is. You said core?
Yeah.
Oh, well, if we were putting it in there, we would move
Oh,
that
okay.
first.
Oh, if not, then throw it in this same BioBox 3 because we can find it there also. It's easier. You just make another sample number. Yeah. BioBox 3.
So again, none of this is as easy as it may look on screen. That was a pilot picking up a snail while just looking at a video monitor and manipulating an arm 2.5 kilometers below the ship. So that particular view just had one camera view as well, so it's a pretty delicate grab to fish that out of that clump of tube worms.
Right, and 42 is also, okay. 42 is the tube worms and the mussels. And 43 is the, what's the name of this one?
Phimorhynchus major.
Phimorhynchus, no? It's the same species Ian wants also?
No, this is a new
Okay. Okay. This one, Phimorhynchus Meyer.
This is a connoidale, like the ones with the harpoon rattled up.
Okay. Okay. Here we can get one more, and then we need to head back to Tica.
It looks like that snail in the middle of our screen is the target there.
This one?
Interesting to see they're all of similar size. The first day we saw a lot of large ones. They were all large.
They're also not so small.
Hmm?
Also this one.
And here comes the scoop.
What's my plan?
He's on loose. It's gonna be a tough guy to get.
Oh,
I'll try it.
yeah.
And the pilot's bringing the rams in, and that's actually moving the vehicle forward a little bit to make this sample a touch easier.
One that's laying on loose stuff is obviously easier.
I look around a little bit.
Right there. I just lost. There it is. Right there.
The crook of those two muscles.
Ah, yeah.
Yeah, it's okay. It's the previous one, right?
Mm.
Didn't get.
So the team has identified a different sampling target that may be a bit easier to grab. Or at the very least, Chip will be able to see it on screen a little better as he samples it. Because the views we have up on our screen right now are the views the pilots are using.
I saw it for a second. It was back there.
That's so cool. No, it is the other one.
I'm just gonna try it. Fly it anyhow so you can see what's in there.
Giving the shake a little scoop. See if that snail is
No.
hidden at the bottom anywhere.
It's not there, no. Because I can see it over there. This is here, no? Or is this one? No. Somewhere.
There he is right there.
Where? Here?
Ah, yeah.
Okay, just forwarding. Okay.
Cool.
Okay. Two of those things, and then we. Yeah, it's in. We have two now. That's good. Let's go.
Nice.
And continue with what we also have to do.
Excellent zoom on the side cam there.
We can store the scoop.
We haven't been using that box.
We will go to this waypoint 15 we took today. This is just a cold basalt area where we deployed some of the school experiments to take pictures.
Sure. Okay. He's just asking for media department. We're wanting some beauty shots here. Grab that real quick.
Okay, sure. I didn't hear it. One large tube room above the other, all lining up. Okay. Just nice tube room. Nice tube room. Which one here? Take another one? Yeah, because you can make the background black and then it just comes out. Yeah. Okay. Screensaver picture. No? Already defined.
This is how we make the next generation of scientists.
Let's see when we go back to the meet.
Oh, yeah.
Because first we go to the basalt, then take pictures, and then we go right where we were in the beginning.
Yeah.
Yeah, yeah. This is Phytocrea. Those are real crabs, those here, and the other ones are squat lobsters. But when you look,
I think that was that crab. Like
the crabs, yeah, this is
that fish and the crab are fighting each other.
really.
Yeah, look at that.
Those here, yeah. I'm sure they eat basically the same, but I don't know. I always try to imagine how it is when you are not seeing anything, no? Just smell and feel. In principle, no, it must be stuck down there. What?
That's all right. Don't pay that fine.
Yeah. Oh, here, it's here. Those two. Sure. They're just. I think. Go away. Okay. 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 Yeah, but I don't know. I mean, bite. Wow. You cannot eat this crab. Yeah. For some reason. Ow! Ouch!
We have a winner. He's contemplating his choices in life.
And now he's thinking, not such a good idea.
Yeah.
Okay.
Yeah, let's do that again.
Oh, sure, man.
I'm hungry for more. That crab's having none of it.
The slowest time I've ever witnessed.
This is
Slow motion.
okay. Slow motion fight. Okay. Could we go back to work?
Yeah.
Waypoint 15, basalt from today. This is the, I think, the green. It's left, it's east,
Right here.
west.
All in one.
Remember, everything's shifted, so everything's been kind of lower. So I imagine 15 is actually going to be somewhere right about here.
That was the one we put in this morning.
Oh, okay.
We put in this morning, yeah. And we will put in then another one, but I have printed out the long leads from today. So this is the basalt area where we deployed some of the school experiments, and we will just check on them and take pictures.
Okay.
What?
And while we
I got a small message for you. Hold on.
Yeah, copy that.
Got it.
No, they just pull off. So let's see. So I need to come around. I just come up. So I need
All right. So, sounds like we're on the move. Just to give you a little map here of where we are, where we're headed.
far away from the school experiment here, but it is not element.
Yeah.
It's very one. No.
That's
I don't know. You want many or you want none? Many arguments, none.
So we are headed down to the bottom of this map,
maybe better.
down to what is labeled waypoint 15.
Monica,
Okay.
waypoint 15 is not what they gave you before.
This morning you did not take it. It was.
So I have waypoint 15 here.
What? Yeah, this
What
is
do you want
50.
me?
This is 50. I just wanted to see if it's the right number.
Traveling through some venting fluid there.
The deployment on
Nothing
our
too
side.
hot, but bumped us up to 2.5 degrees C or so, whereas we've been typically seeing about 1.9.
We are here already, see?
Ah,
This is the place where this is basalt and the vent is in next. If it's one I can take here, or I go to the vent afterwards,
Yeah,
which is denser, and I take it there, but we would set it there.
yeah. Maybe, yeah. 'Cause last time we had very few, so maybe.
You want
when
more?
the
Okay,
same-
good. Then,
You want the
okay.
highlight video on it?
Yeah, put on the highlight video. We just.
Grab it.
Was? Na, das probieren wir morgen. Weil, das, ja, weil ich hab nicht gewusst, wo ich hingehen soll, wir müssen weiter weggehen. Er muss sowieso morgen Basalt geben. Übermorgen tun wir das. Weil das hat ziemlich lang gedauert und ich wollte unbedingt noch viel schauen. Okay, so we go low. Okay, so we just go.
Favorite.
They like the meat. They like the
You're
meat
using the camera now, so.
better than the potato.
Hmm?
There's also a.
Okay.
Is that a.
This is the other one. Ah, you know, they sit on the liver.
Yeah.
Okay?
Yeah.
We just can take a picture.
Fat.
Fat.
Fat,
Pork fat.
meat, liver. Meat lovers, liver lovers. Okay. Oh, there's another one below. Okay. Okay, this is good. You have a video and a frame grab? Okay. So this is basically the basalt deployment. And from the other one, can I take the camera?
Sure.
Okay. I will go here because. Okay, you can take. I'm turning it a little bit.
There's a lobster underneath.
There's a squat lobster on top and a crab.
Yeah, it's for today, and then I make a waypoint once we are finished in this area.
No worries.
We're gonna put these up.
So we want to go in there right now?
Yeah.
Yeah, we're just gonna put that into the machine.
Which one you want to do?
No, we last long and then the end will be feet like that. So. Vehicle, real time out there. Vehicle saved.
All right, we've got a little bit of a handover happening here with pilots.
Yeah,
You can put the laser.
Huh?
You can put the lasers.
Yeah, it's okay. You will see anyway because you can measure it with the frame of the kitchen stove. Good.
I know, that paint bid was saying,
Oh,
yeah, because that's the NUS bill.
oh, okay.
Yeah, that's the new thing out there.
I think the area must be
Well, that's
Well, we
Spanish
have-
behind us, yeah.
yeah.
Can anyone see that? One five, we got five. They just name it.
Buenas tardes, buenos días o buenas noches de donde sea que nos estén viendo el día de hoy. Bienvenidos de vuelta a el livestream. Entramos de nuevo a la sección de narración en español de la expedición del día de hoy a bordo de el Falcon 2, viendo imágenes hermosísimas gracias a el ROV Sebastian. En este momento tenemos en pantalla una anémona preciosa del fondo marino acá cerca de el Tica Field en la dorsal Albatross. Acabamos de poner unos experimentos diseñados por niños que tenían la pregunta de qué era lo que los animales de las zonas profundas iban a preferir comer, y se puso
Hast du was für mich? Das sind 100.000 Morgen.
y se puso una reja con pedazos de carne, de grasa, de hígado, a ver qué era lo que preferían los animalitos. Vimos que el hígado fue el más popular de todos. Había ahí un cangrejito, una langosta, pegados comiendo pedacillos de hígado. Es muy bonito ver cómo los niños también tienen esa curiosidad científica. Deberíamos seguir apoyando ese tipo de pensamientos. Ahora en este momento nos estamos moviendo al siguiente
That was
sitio.
30 seconds.
Yes, you went right
All
there.
your colleagues should like that, but
Yow! Okay.
Ahí estos círculos blancos que vemos en pantalla es justamente los experimentos diseñados por los niños en escuelas. Esta es una escuela distinta, entonces la rejita tiene también, bueno, tiene un dibujo distinto al otro, pero tiene frijoles, tiene una papa, tiene grasa y carne. Vamos a ver qué encontramos acá.
Was ist mit dem da los?
did the anemone migrate?
The middle parts are, one is shifted and the other one is gone.
Damn.
Ah, no, warte mal. No.
Very cool.
Okay, let's
Al cuarto de control acaban de entrar Max, que es el artista a bordo de esta expedición. Si ven, atrás de los experimentos de los niños podemos ver que hay una escultura hecha por él. Entonces, parte de su proceso artístico fue poner la escultura acá en el fondo y tomar imágenes y videos de la escultura en el ecosistema marino de profundidad. Súper interesante, hay que seguir mezclando la ciencia con el arte. A la par de la escultura vemos una anémona, cangrejos, con el fondo súper dramático de las riftias.
They don't take anything. Well, we will see what happens because we just leave it. Yeah, but the food is not popular.
Como siempre pueden poner en el chat sus comentarios, sus preguntas, y acá con demasiado gusto las vamos a ir contestando.
This we have a picture, no?
Yes.
Now we go to the other one.
They're like, what is that? aluminum, plastic.
The,
Oh my god.
this room is like
Okay.
Ahí vemos un camaroncito encima de la escultura.
It's pretty exciting.
El artista Max está bastante emocionado.
That is pretty exciting.
Huh?
You can do like this highlight video for max 1. I have to make it short.
Yeah, your art seems to touch lemons for some reason. The idea is really
Yeah,
like
no, I mean, it's strange. It's odd, very strange. You got an eel, anemone.
I'm sorry.
It's a good spot. You can eat a beaver and
It's such a good spot. That's Monica and I teamwork.
Let's say crap.
I hope we moved in.
We needed to work something else also. We need here to
I mean,
fire the Niskin bolt, so we just can stay on this video. This thing
I'll actually fly out. I need to try and see if I can dinner.
What are you worried about?
That's why this is.
You know, set up just on that one, okay?
Hands free. That's good. I already did that. So
Yeah.
are you ready?
You're gonna fire the Niskins. 1, 2, 3. Okay.
pretty insane.
So this is Tica, just call it Tica. Niskins 1, 2, 3 is 42, 43.
no, what is
No.
that? 44, 45, 46.
Yeah. Thank you. 44, 44.
Yeah. So these already triggered.
Aún hay muestras que hacen falta de tomar, entonces los científicos principales están acá revisando el plan del buceo para saber cuáles muestras hacen falta y reposicionarnos para ir a tomarlas.
Bar 4 is the pool. Yeah. We did that to 3 rooms from the good side, the masses from the good side, everything else is broken, is controlled. Find that. Find something very careful, nothing else. This is a walk we keep also in this box, this is for me. So this is 3. Sorry, the number 4. Passes in the golden life there. There's the life. Number 3. It's a few large. Yeah, that's what it was. Oops. Special guest for Jan. And blocks. Try to steal from here somewhere.
What's that?
Wait.
1,
2, 3, 4, 5.
En este momento se están tomando muestras de agua con botellas Niskin. Estas botellas son básicamente un cilindro que tiene la parte de arriba y la parte de abajo abiertas, pero que tienen una tapa que cuando los pilotos mueven estos switches que acabamos de ver, las tapas se cierran a la profundidad específica en la que estamos. Entonces se toma una muestra de agua de la profundidad en la que está el ROV. Estas muestras de agua se van a utilizar para un experimento sobre partículas, en el que se analizan las partículas y las comunidades de organismos que viven en ellas.
Go up to the
has a lot of the colors of the environment. Oh man.
How do you want the video? More, because I cannot, so I can go closer in. You can go closer in.
Maybe closer in and a little higher up. Yeah, that's pretty. A little bit back now. Yeah.
En este momento se están tomando tomas del arte que tenemos acá en pantalla,
Maybe a little to the left, sorry.
dirigidas por el mismo artista Max.
Links, right? Yeah. Oh my god. Yeah, that's so insane.
Then we leave it like this and then we actually set it in the soft.
We should leave it here for a couple of days, no?
As you like. You can
I think so.
leave it. And
Yeah, I think we should.
come back tomorrow to check again for the jiggle and stuff.
Yeah, let's do that.
This is a video highlight.
Yeah, video highlight. Is it running already?
Sabine? Sabine? There's a question in the chat about the function of the plumes of the Rifia.
Then we take the waypoint from here.
Yes,
I don't know if you find it easier, but number 16.
Or can you text?
I will ask them in the chat.
Okay.
One, two, four,
Oh, Connor Johnson already answered. Si no están viendo los comentarios, nos llegó una pregunta sobre cuál es la función de las plumas rojas que tienen los gusanos poliquetos riftia, que es uno de los organismos más abundantes acá en este sitio, en estos ecosistemas. Muchas gracias a Connor Johnson que respondió la pregunta. Exacto, estas plumas rojas son justamente las quietas de los poliquetos y ayudan en este caso a movilizar agua a la parte de adentro para que ellos, las bacterias que estos organismos tienen adentro, logren alimentarse de los químicos que hay, logren hacer la quimiosíntesis para luego pasar todos los nutrientes al gusano. Esos gusanos son muy interesantes porque ellos no utilizan sus quietas para agarrar partículas para ellos alimentarse, sino que adentro tienen una comunidad de bacterias que logran fijar el carbono que ellos utilizan. La sangre de estos gusanos también es muy interesante porque además de tener oxígeno como la de nosotros, tiene también azufre.
Alright. The shrimps seem to kind of annoy everybody, huh?
Wait for 60. Okay.
50? What did I say?
16 or 15.
60. Oh, 60.
I think
60. Yeah. 15 we have already. 60 grams.
Acá nos estamos quedando un rato para tomar buenas tomas del arte submarino. acá a mi izquierda tengo a uno de los pilotos del ROV. Preguntémosle qué piensa de este arte. Chris, what do you think about the art of Max right here and having art in the?
What do I think about it?
Yeah, what do you think?
It's new. Cool. I think that, you know.
Have you ever put art underwater before?
Sort of. Ooh, that's we put plaques and other things like commemorative things down on several occasions. Never anything quite this elaborate.
Max nos acaba de comentar que le parece que es algo diferente y que nunca antes había puesto algo tan elaborado bajo el agua. Muchas veces algunos experimentos implican poner nuevos sustratos en diferentes ecosistemas para ver la colonización de los organismos, pero los sustratos suelen ser placas, pueden ser de arcilla, de algún tipo de piedra, incluso plásticos se utilizan a veces, pero nunca se ha puesto nada así, lleno de tantas cositas particulares como el arte que vemos en este momento.
Oh, the one you just did? With 116? It's right there.
I know, but it's not short.
Oh.
What? Oh my god, it's a seal. Yes.
Una pregunta que sale en el chat en este momento, ¿qué es lo que estamos viendo? Estamos viendo el arte del artista a bordo Max Cooper. En este momento estamos haciendo unas tomas, grabando el arte en el ecosistema de profundidad. There's a question in the chat about what are we looking right now. This is art. This is a sculpture made of the artist Max Hooper Schneider. So he is the artist on board. And right now we're just taking a few shots about the art in the marine ecosystem. En este momento vemos que el agua tiene como muchas ondas y la imagen se ve un toque, se podría decir que borrosa. Eso es justamente por el flujo de agua caliente que está saliendo de las ventilas. En este momento tenemos un flujo bastante fuerte, entonces la imagen se ve un poco más distorsionada.
They were like that in the day. Wow.
You think we could pull it out a little bit now?
There you go.
Yeah.
How's that? Change the width and tolerance, so let's go. With one tolerance.
Oh, yeah, yeah.
Yeah, that's good.
Good job.
Deze heb ik genomen, de standcijfer niet. De boven is dat verjaardag genomen of wat.
Uno de los comentarios que acaba de aparecer en el chat es que es muy increíble lo mucho que se puede hacer zoom con la cámara que tiene el ROV. Y es que el Sebastian tiene una cámara 4K, que es la cámara principal al frente, que es la que nos permite ver las imágenes que tenemos en este momento en pantalla. Y si ustedes ven la cámara en vida real, parece una cámara de cine. Es muy impactante. Y en efecto, el zoom que puede hacer esa cámara es muy bueno. Tiene una resolución perfecta. De hecho, que en expediciones pasadas, si ustedes revisan los videos, cuando se hacen acercamientos, por ejemplo, a corales de profundidad, corales negros o octocorales, uno puede ver los pólipos moverse de manera súper clara. Parece casi un estereoscopio, es algo increíble.
Well, yeah, overhead definitely, yeah. All the way out. Or what about just a different? If he comes,
I can give you that camera view.
if he comes in on the camera, how far is the zoom? Interesting. That's not bad. That's not bad.
No, it's also good.
That's pretty good.
Let it run like this, you get it. Also
Maybe some
visible.
light.
Yeah.
Okay. Questo non lo so, c'è sempre un po', non è tutto. Yes, fai che sinistra. Cerchi qualche scuso.
Crabman is coming. Yeah. For sure a life highlight.
Nos preguntan en el chat que si el arte tiene un objetivo específico a modo de colectar datos o si lo utilizaremos para un objetivo científico, y la respuesta es que no. En este momento lo que estamos haciendo es solo seguir la guía artística de Max, que utilizará los videos para luego él terminar el proceso artístico. Vamos a tener que estar pendientes para ver cuál es el producto final.
Cangrejo is coming. Huh? He's going for the fake octopus.
Looks like Godzilla.
Crabs. Dude, look at it from
Acá el piloto Chris está diciendo que el cangrejo que está en este momento como interesado en la escultura de Max parece Godzilla, ¿no? Crabzilla, maybe.
Sounds good. That sounds. Yeah, that's cool. That looks like fruity pebbles.
Acá se está intentando ajustar la cámara para agarrar una imagen mucho más acercada de este cangrejo encima de la escultura, pero podemos ver que el flujo del agua lo está dificultando un poco. Ahí vamos viendo cómo va mejorando la imagen, se ve mucho más claro.
I wonder if they're gonna pick it up. I hope it gets picked apart.
Max, how do you feel right now?
Really good.
Acá está presente Max, claro, dirigiendo todas las tomas que se están tomando en este momento. Está bastante emocionado.
So picturesque. That's great. That's perfect combination.
Just for this, where did you get this? Did you
Architecture model store.
Where?
architecture model store?
Architecture model store. She responded a question in the chat about where did Max get the little people. It was in an architecture model store. Hay una pregunta en el chat sobre dónde fue que el artista Max encontró estas pequeñas figuritas de personas. Fue justamente en una tienda de modelos de arquitectura.
I mean, it's so we can't. I mean, it's so hard to not apply human sentiments, but he's curious. No, I mean, they've got to be curious. If there's something in the aluminum, the miniature. The fake sushi tentacles. I mean, it's gotta have some.
Es interesante porque algo que hemos notado es que en todas las inmersiones que hemos tenido, los cangrejos han tenido un momento de protagonismo en algún momento. Siempre están muy curiosos.
What are the sensory?
Smelling.
The smelling?
How does plastic
Taste and
smell?
also smell and tactile.
Maybe the plastic with the
En este momento las científicas principales y Max están discutiendo por qué será que este cangrejo está tan interesado en la escultura.
Like a massage or something.
Might give off some, it's in warm fluid now, so the plastic might give
The
off
plastic
some.
might smell.
Yeah.
Something's going on. Something good is happening. It's like a drug.
La científica principal, Monica Bright, está explicando que los cangrejos suelen tener de manera sensorial más que todo tacto y olfato. Probablemente el plástico de la escultura esté liberando algún tipo de químico que el cangrejo puede detectar por medio de su olfato y le llama la atención.
So the opposite of desolation.
Yeah.
Total opposite.
Yeah, and that's the contrast, right? Because some of the weight, like a it's like an oasis, like on the desert.
Yeah.
That's
That's bacteria.
Yeah, that's the one.
You have no idea.
That's not the end of it.
No. Yeah, no, that's colonizing the outside.
That's why.
They use it basically as an attachment surface.
Yeah. I can see everything has.
Yeah. So the bacteria like to go in the cell, makes perfect match, and then you can access the oxygen and sulfide.
Is it the same thing as the bacteria in the crab?
Probably, yeah. Actually, the crab might have
I saw that.
Yeah, 15, yeah. You can stop the highlight video. Are you happy now?
Yeah, really happy. Very happy. Very happy.
We
Yeah,
come back tomorrow.
yeah, we'll come back tomorrow for sure.
The crabs sits there completely paralyzed. Married to your plastic.
Yeah, then if the crab dies, I'm thinking that I'm gonna get like an
Al
animal
parecer
rights.
vamos a dejar la escultura acá por toda la noche y vamos a venir mañana a ver cómo se ven las esculturas y hay más animalitos acercados o puestos encima de ella.
The beet?
No, the liver.
The liver.
And you're eating the liver. So we come back tomorrow and it doesn't take long to go and take
Yeah. No, it's exciting.
Can you look down a bit more? What are you trying to get?
Just suck through the muscle, isn't it?
Yes.
I can do that.
En este momento vamos a tomar otra muestra, en este caso con este apéndice de succión que tiene el ROV.
Go for it.
Just not too close to the experiments that we don't.
Estas muestras de succión se hacen cerca de las almejas y van directo a un contenedor que tiene una malla fina. Esto es porque lo que estamos buscando son copépodos para un experimento de un estudiante que está a bordo del Falcor 2. Los copépodos los podemos imaginar como camarones microscópicos, pero tal vez con un poquito más de patitas.
Stop on that. Come on.
La toma de estas muestras se hace con dos pilotos a bordo. Uno está moviendo el brazo que tiene sostenido como la boca de esta aspiradora que tiene el ROV, y el otro se encarga de la potencia con la que se aspira el agua.
What do if I tag on Instagram Schmidt Ocean Institute? Sure. Is that what I'm supposed to say? Got it? Not metallic, official.
En esas muestras, a pesar de que se toman para buscar estos copépodos, siempre salen un montón de cosas distintas. Muchos animales, organismos pequeños que están en la columna de agua. Porque estos ecosistemas hay que recordar que son sumamente diversos. A pesar de que tal vez a simple vista no se ve así. Pero bueno, en este momento en pantalla tenemos un montón de animales distintos, además de las almejas. Encima de las almejas vemos varias lapas pegadas a estas. Si vemos en la esquina derecha inferior de pantalla, podemos ver que hay varios cirripedios. Arriba de los cirripedios tenemos una anémona. Muchos animales hay acá.
Yeah, sure. That'll be number
48.
Yes.
48. I don't know which section is it.
Yes.
The charts were.
Therefore,
En este momento se está parando de succionar agua porque se va a cambiar de contenedor a donde la muestra está siendo repositada.
Same thing.
Yeah, but I guess it's too far away.
You never know.
What's that crab?
Can you bring
called?
the? Oh no, you can't. Is that right? Are you on that road?
I'll try.
I just don't know.
Alex? What's the name of that crab?
Well, it brings you in a feedback, right? So,
Is there a common name?
not much. More around the world, that's just not
You went up there?
Los sitios en donde se toman estas muestras no son al azar, sino que en este momento en el cuarto de control tenemos a una de las investigadoras principales que le está diciendo a los pilotos en qué sitios tomar las muestras. Y ellos, en la mejor de sus capacidades, posicionan el ROV y posicionan el equipo para poder llegar a el lugar donde se quiere tomar la muestra.
Spin this thing, 'cause the handle's turning.
En este momento la posición está un poco incómoda, pero los pilotos lo están logrando.
Get all this stuff. I don't know what that is.
En una pregunta del chat mencionan que por qué este apéndice de succión del ROV está tan rayado, que si es porque las conchas de las almejas son filosas. Y pues sí, en realidad los bordes pueden ser filosos, también si hay partes de concha rotas pueden rayar el material del que está hecho esta parte, digamos, de la aspiradora del ROV. Pero también hay que recordar que estamos en este momento en sustratos de roca de origen volcánica y esta roca es muy filosa, es casi como un vidrio. De hecho, cuando el magma llega y se enfría, la roca que está encima, la que está más fría, se convierte en obsidiana. Y esta obsidiana se laja y los bordes son muy filosos. Es casi como una navaja. Uno tiene que tener cuidado cuando lo maneja. De hecho, los científicos a cada bordo, cuando tienen que manejar las rocas, lo hacen con guantes y siempre teniendo cuidado porque si no se pueden cortar. Y bueno, con estas imágenes yo ya me despido. Volvemos otra vez a narración 100% en inglés. Que tengan muy buen día. Y como siempre, nos vamos a ver mañana porque vamos a tener narraciones en español al menos 1 hora cada día que tengamos buceo con el ROV Sebastian. También estamos pensando en hacer narraciones en diferentes idiomas, ya que a bordo tenemos una gran diversidad de nacionalidades, así que si les gustaría que se hiciera narración en un idioma en específico, pónganlo en los comentarios.
All right, well, it sounds like we will be leaving the art here for at least another day. We came back and checked on it, and it seems to be holding up quite well, actually. So we're not too concerned about it falling apart, at least not yet. We've still got some more work to do today, and tomorrow, with the deployment of experiment number 3, we will have a nice empty spot on the porch. So.
The rock breaker is between the firebox 3 and the large firebox.
I thought it was taken off.
I don't know.
What?
No, I mean it's on the seabed. That's what I mean. It's somewhere on the seabed. So,
Yeah.
Yeah. So,
Yes.
yes. General idea.
Then it is at the side 3 and the
It's at the side, yeah. We took it off because the ROV was in the queue. No, somebody else
It's
said
definitely heavy. Yeah.
So it was better
Which
to-
one is that? Side 3. Left
Carl probably will take it off.
know where the experimental sites are. So the 3 boxes. So this is waypoint.
Yeah, yeah. That's good.
Brief confusion when we were asking for the rock breaker on the front porch, and then we were called, oh yeah, we dropped that off because it was quite heavy. So we're gonna head back and pick that back up.
Yeah, when I got to the seabed, I was like, all right, I stopped descending.
Mm-hmm.
And already was just like, no, we're not doing it.
Oh yeah.
Yeah, there's a bunch of metal on them.
Yeah, it was. I think the estimate on that weight was something like 20 to 25 kilos. Right. So.
Hey, this is lawn stuff. Ja, sure. Lawn stuff.
But that's back over by experiment site 3.
There must be somewhere for you.
Oh, well, they're already, you can already
Yeah, we're
see.
not that far away, like, I can see the balls already.
Fortunately, this area is pretty compact.
So close, huh? Everything. Yeah. But now, so we work from the other side. So we have to go over this.
Yeah, we go.
Yeah.
Some interesting glints of ROV Sebastian's lights
I think it should be
on the
something
acrylic of one of the experiments there. For anyone who might just be tuning in, you are watching live footage from a remotely operated vehicle named Sebastian. So this is about 2.5 kilometers
Here it is.
below the surface of the Pacific
This
Ocean
one? Or is it another one?
on the East Pacific
Ah,
Rise
here, yeah.
at
Yeah,
a
that's the weight.
hydrothermally active venting area known as Tica vent area.
Take that time out of the way back, don't worry.
And we're beaming this footage from the surface vessel that is controlling ROV Sebastian, and that is the research vessel Falkor 2, owned and operated by Schmidt Ocean Institute. If you've never tuned in for one of these dives before, we do try to stream whenever we have an expedition going and the ROV's in the water. And we're planning to do expeditions through the rest of the year at least, and we do have plans obviously beyond that as well, but the expeditions for the rest of the year are planned out. You can learn more about them at schmidtocean.org. And in fact, there should be a pinned comment in the chat with a link to the information page for this particular cruise, the Underworld of Hydrothermal Vents,
The thing is that we drop it somewhere where there's no slope.
or hashtag Vent Underworld over on Twitter.
Das muss nur so weit. So. Und dann müssten wir leider noch das schaut der Spitzen runter und dann schauen wir mal, was das oben ist, was wir direkt von der Okay.
Right, so back to the original slot.
No, we go away from, we stay in this area, but away from the
Yeah.
mesh boxes and try to find a relatively flat, I don't know, flat space and cracks are everywhere.
Crack, but it doesn't need to be venting in it.
No, it just, no, it doesn't need to be.
Press one.
Yeah.
And I think it was made so
You gotta dig.
it should
Drop
hang
straight
really
down.
straight.
Yeah.
Yeah, okay.
Drop it. Oh, stuff. Which one?
That's the plan.
That's awesome.
So as Chris just enthusiastically learned, the point of the plates that we're carrying now. I can actually put up our situation camera where you can see them a little better. Those are for breaking rock. We will be needing to collect some of the rocks around here, and we're just trying different approaches. We've used the crowbar, the chisel, and really crumbled up some stuff, but the method for using this plate is it weighs about 20 to 25 kilograms, and we're just going to drop it. So more of the wrecking ball approach.
Okay. So flat.
So 2 experiments over here.
Yeah.
I'm thinking maybe something in here.
This is, I think, going like this. But
I'm looking at the center there.
also actually, where the plates are here,
Yeah, that's pretty
this looks pretty flat.
So let's see what we got.
No, if we go down here, we have the firebox one, there's nothing in it. Anschauen. Mal anschauen, wie das.
Okay, so, yeah.
Okay, is this flat?
Reasonable.
Reasonable? Can we go low first so we can check it out?
So with the
Try to aim.
experimental mesh boxes that we have deployed, when we lift those up, we are going to want to sample the rock that's underneath them. And so figuring out perhaps the best approach for sampling this stone is an objective now.
I think it might work too, like.
Further up it's...
Something we noticed with the chisel is it mostly just kind of turned it into rubble. And so we're curious if we can strike it, perhaps it'll crack a larger chunk. But we'll see. You never know until you try.
Like there is quite good.
This here?
Now the plates that you can see on the seafloor in front of us, those are actually left over from submersibles that have visited the area. This is actually a well-studied area, and those are ballast plates. So something that an additional weight to change the buoyancy to be a little more negative on a submersible, so they can get down here quicker, easier, and maybe stick down here a little bit more effectively, but then they can drop those weights when it's time to surface for more positive buoyancy. And so those get left behind. They are metal plates. The seawater does slowly corrode them away. It is always kind of interesting to be cruising along and come upon the plates, and you realize that that means that someone else has been in this quite remote area exactly where you are now. This wouldn't be a great spot I'd anticipate to be dropping landers, but landers can also use ballasts like that. But typically, this sort of terrain wouldn't be ideal for just blindly dropping a lander. As you've seen, it's quite steep. It's more in abyssal plains and that sort of thing, where you can just drop a lander and be relatively sure that it'll land somewhere it won't just immediately flip over.
This is also reasonably flat, no?
Yes.
Seems like we've got probably about another hour on the bottom or so. Yesterday, I know that when we wrapped up the stream, We wrapped up over on Facebook, and we still had some time remaining on YouTube, so we kicked it over for ascent on there. So if you're watching on Facebook and we kind of wrap up the stream and you want to stick around, you want to see some more, you'll probably head on over to YouTube. I anticipate we might try and do that again today. Not sure that that's going to be an everyday thing, but we'll try and give it another shot. If you're on YouTube, you can stick around, and hopefully we'll see some good ascent.
See what happens when we try to break here. What do you think? Probably I would right here because it's more expensive. Yeah, okay, this is, but I don't know if this is.
I'm not scared, if you're not scared.
How high you may drop it from?
I cannot see this, yeah.
I'd say first maybe try the, keep custody of the thing.
Just look if it's deep or not.
Just roll it where it's a little more vertical. You might have to grab right in the middle of the white tape.
Yeah.
So that it's straight up and down. There should be a little knot right in the middle.
If I grab this further to the right, so yeah, okay, I got you.
Just get that big knot, that'll make it nice and vertical.
Got all the cameras backwards.
Who drifted?
Yeah.
Roll your jaw a little bit straight.
Get really close.
Roll it the other way.
It was going the wrong direction, but the other way.
There you go.
You want to drop it like this?
Wow, this is
Yeah.
perfect.
Yeah. Just careful you don't hit it with the arm, you know?
Lift up for me, close.
Okay.
Let me try to hit it like this first.
Sliding into it.
Drop it.
I see little divots when you're doing that.
Yeah, it is making little dents. Nothing substantial, though.
Main thing with this, you'll be able to hit the same area over and over, you know? If you drop it, I don't think you would be.
Yeah, this method allows a little more targeting, but if we're just dropping it, no doubt it'll catch an edge and glide off target. Yeah. I know after we spoke about all the fragile nature of the rocks, we pick an area where it doesn't care.
But I think if you would try in and then click the other and
Then loosen it, you know?
Right, well, we use tripod then.
This,
Or the chisel in and then let the
the
weight
chisel
fall on the
in,
chisel.
because this is a good crack. This, no.
So I will try to get the chisel in this crack and then let
And
the
move
weight
it,
fall
you know,
on the
like we
chisel.
did.
Might bring out the
I drop it one time just for fun.
the chisel.
Don't use the chisel to pour.
Yeah.
Use it.
Mm-hmm.
Don't have to drop it.
I drop it once.
You can drop it for sure.
I'm just gonna buy.
The aim. This.
You might have to fly up to really get the thing on that area. Or
sort of just like come off and run into it. Just keep this the same. Left a little bit.
You probably have to angle your jaw downwards too,
Yeah. So it's kind of not be as far away though, so I have to go to the left. Yeah.
Yeah, that's going to go at an angle.
Ready?
You want me to push on what?
Oh, I just. That's alright, that was bad. Yeah.
Okay.
Well, we got some muscle samples.
So now we know what was a great idea. Did you? No, it's just
Just hit the muscles and kind of slid.
You were in a cliff in the beginning of the my shift. And in the edge of the
Muscles seem a bit resilient here, honestly.
But we had like a big plate at one of the dives already, very loose and lifting up, you know. And
But could you try to put the chisel?
Yeah,
in
that's
the
what I
crack
mean,
and
with the
then, like,
chisel
let
in the
the
crack.
weight fall on it?
Like a hammer on a
Yeah,
chisel.
Yes.
Yeah, try that. There's a weight thing, that thing's pointing heavy.
Oh, yeah.
Oh, so that's medical distance. Yeah, small.
All right, let's give the chisel a shot here.
I can grab that if you want, Rob. I don't mind playing.
Let's see what that we grab it, see where you grab it.
All right. So here's our chisel slash pry bar. There is a crack here already, so I think they're going to try and give that a little pry.
Alright, so, see that V there?
yeah,
Yeah, that's what I want to know. So we want to re-grab this then, right? So you can whack it with the weight. Sure. So we're going to push back in again. See what place we can grab this?
Yeah.
this here, no? We said
Yeah, that's the section.
this corner.
So we grab that halfway down.
So I'll highlight real quick what we're looking at here. There's a kind of a corner. A little corner in the rock that we're trying to get, perhaps. I think right about there. There's kind of a joining. I want to say that's where we were looking at.
Alright. Now we grab it. You grab the weight, but I'm kind of scared to shoulder down enough for this alone.
Yeah.
So you can see one of the experimental boxes in the back. If you didn't join us for the placement of these boxes, we did one yesterday and another one 3 days ago. We are currently planning to deploy a third tomorrow, and those boxes are actually sealed to the bottom with a silicone, like a little O-ring, and some silicone caulking that we put into the cracks. Try and seal it up. And we're monitoring whether or not any fauna, any little critters or even the vent bacteria that associates with these critters, if any of it's really coming up through the venting fluid itself, arriving at the venting sites from up from underground versus just drifting down from above.
And then we'll just scoot forward if we need it. Right now, y'all want me to just try and fly it? Or do y'all want to hit it with the weight?
Last time I went in here, I was able to move it. Give it a shot.
Okay. And if that doesn't work, we can grab the weight and drop it on top of this chisel, you know? Yeah, that goes.
Pilots currently discussing amongst themselves the approach here.
Yeah, I
There's a
don't
couple
know if it takes
couple
it.
different ways we could use this pry bar.
You're a little bit outside of the crack right now.
I was just the reset.
Yeah, yeah.
So we have one pilot at the controls of the ROV, two pilots controlling, one controlling each manipulator by themselves, and then Professor Monica Bright is largely controlling the camera here right now as well.
What's the captain's?
Yeah. Lures and medicine.
Not the air grabbing in. All right, let me see if I can restart it. I think this is this on. It's just not going to do this.
Maybe go to this break. Because there's the two groups in here, this one. There's a break here.
Yeah, but just to change arms. This one's
Yeah, there's a discussion of sort of what do we do when we're not diving overnight. Some dives or some cruises will do mapping all night, or we could do CTD casts, getting oceanographic data of the midwater column. But this area is quite well studied, quite well mapped already. So for this one, we've kind of just been drifting a little at night, not going too far, but it's not important that we're doing instruments or anything overnight. Got a nice grip on there, and we'll see how it goes.
I'm going to move it out because I want to go into the top track. You see on the white line on it? Yeah, right. Can you reach it?
Well, it's not guaranteed.
Yeah, I'll move it.
All right, so we are going to try and go for that little further away crack there. So we'll just have to scooch a bit closer. What would you say the reach is mostly on a useful reach for these manips? A meter or so, meter and a half. Yeah.
Depending on what we're doing, like with this, we have to go this angle.
Mm-hmm.
Makes it a little bit shorter.
Yeah. This one's got a bit of a shorter reach because we have to come down with the pry bar. But if you were just reaching out to grab something, you'd say about a meter and a half for grabbing that. Yeah. Okay.
So this one right here below me.
And some folks noticing the larger tube worms in the back. Yeah, if you're just joining us, once this dive's done, we will have the full video up. You can still scroll on back through it, and there are certainly some huge tube worms, just massive. A couple meters, at least a few meters long.
Let's try tube worms, Chris, on your left-hand side.
Hold on. There you go.
So for tomorrow, we're looking to deploy experiment number 3. If you've tuned in for any of the prior experiment deployals, or deployments, been a while now. If you've tuned in for any of those, you know that we've kind of got to sit still for a while, and so tomorrow we're hoping maybe we'll be able to show you some of the lab space on board. We'll get a roving camera, and during that time when we're kind of just sitting there waiting for the dye to stain underneath the experiment box, we're going to try and just go for a little roam on main deck here and show you some of the lab spaces. So there you can see that rubble that just popped up. That's kind of what we've gotten typically. Because even if we can make progress deeper in, it just all kind of turns to that rubble. Yeah, certainly no promises on the lab space walkthrough, but we like to do that, and the deployment of the experiment and staining of the experiment is a good opportunity for that, so we'll give that a shot tomorrow.
Just every time it does, I just push the vehicle off. It's not very good.
You're sitting when you push the just. Are you sitting when you put?
Yeah.
Okay.
Yeah, the plan is to do a lab tour, and we do have a setup for that. We'll basically use the roving camera setup that we use for our ship-to-shore programs, so should be able to walk around with that. And then folks that stuck around for the ascent last night got a brief little glimpse of the hangar just as the ROV popped up out of there, out of the water. And the hangar on Falkor 2 does open on both sides, and we can deploy the ROV out one side using our A-frame, and then there is a smaller J-frame on the port side where we deploy our CTD. Whoa, got a sword and a stone situation there now.
Alright, I'm gonna do that.
There was no light.
No. You turn the light on and it just blinds me. no storm.
Yeah, we do have some moon pools on board. They aren't used with our current equipment, but those could handle another style of ROV deployed, where we drop it down through the moon pool, which is kind of a door in the middle of the hangar that goes straight down to the sea. Sebastian's not deployed through that moon pool, or not deployed through a moon pool. We deploy Sebastian out the side, but there are styles of ROV that can be used with those moon pools.
Alright, where's that hole? Stick this in there, I'll be able to re-grab it. Where at?
I thought see that you took that area there, straight down south.
Nope. Got to hand it to you there, Arm.
Someone asked if there are more powerful tools for this sort of thing, and certainly within like industry, there are larger, heavier, more mechanically oriented ROVs. But typically, if you need to be drilling down into rock, that would take something like a surface drill vessel. The Joides Resolution is a ship that does some very cool deep coring. And that's an example of a scientific vessel that can really get the cores down into the rock. But that is actually running all the way down from the surface from the ship up top. So yeah, just speaking briefly with Chris here, he's familiar with some rock drills that could be ROV controlled. Yeah, that's the other thing someone notes, right? Is one of the problems you run into here is as you're pushing the rock's pushing you, and so it can get difficult. Doing anything like this against a firm substrate, the ROV just tends to push itself around.
Alright. You grab it. Right there for me, please.
I've cleaned like the inside of larger tanks before while on scuba, and it's the same sort of thing. If you're trying to scrub windows or something while you're diving, you just end up pushing yourself away. And so we would use basically a suction cup that you'd use for removing a pane of glass in one hand and just suction yourself to the window. And then the other hand, you could actually get some force behind the scrub if you were trying to clean. But it is certainly a problem to consider. And you'll see, even sometimes with the push course, for example, if we're pushing down into firmer sediments, firmer substrate, Sebastian will shift around.
Das ist nicht so toll, das chippt ab im kleinen Vogel und was. Nicht. Die sind jetzt immer drauf. Ja, das kann ich ihnen machen. Aber das ist irgendwie. Ja, abhängen. Und wir schauen, was wir jetzt machen. Da kannst du total weit reinfahren, schau mal das an. Das ist der Spalt, ne? Ja, das weiß man nicht, was du unten nicht reinkommst, ne? Wie dick das ist, so dick ist glaube ich schon.
I actually feel like I saw a little movement in the part above it.
See the waves on the other side?
Right here?
No, go over the muscles. And then there's a crack on the other side.
Which side?
Yeah.
Over there.
Yeah, this is where the. Mm-hmm. Yeah.
We'll just have to bring down the parts for a large seesaw and get it in there.
See, it's moving.
Whole plate.
Yeah.
Yeah, it's almost the part to the right
If
And
to watch out
above
that you
seems
don't
like it
lose your
moves
sizzle.
more.
Come on.
Yeah, there's some movement going on, and oh, that's a plate. Yeah.
Yeah.
I mean, you can see where the crack goes down and around and then back up, but it does move. I mean, there's that.
So, yeah.
Wow.
See?
I suggest you do it, just walk away at it.
Yep.
Yeah.
Well, progress. Found a spot that moves.
I wonder if you can mark this bit as well. It seems to go there. Yeah.
Yeah. I'm curious if those cracks go down, and then you can kind of pry it back the other way, but who knows? Yeah. It's tough.
This seems to be broken off, I think, but
Yeah, we didn't run in there, but just that
Yeah.
was solid as well, yeah.
yeah. I was wondering if you have like a, not a sizzle, but like a plate, just the iron plate, and you get it in and a little bit like a little bit in this direction, and then you would leave it and you just drop this thing on top of it. I mean, not on your sizzle, but on something you can, with this like
Like a
something
pry
with
bar.
a pry bar,
Yeah.
not yours, but first this, and then with a pry bar you try to stick it in like this in an angle, and you drop basically your weight on top of it. I don't
I'm
know.
not sure if they drove away, but if you had a longer bar, you get more fulcrum, for sure.
Right,
Yeah.
More
because I
force on it.
think Zach said he has a longer one.
Yeah, like
Oh,
something-
Excalibur actual. Yeah.
Because see, it's moving. Now it moved again. I mean, this may be.
Julie.
It's like this much in, no?
Yeah, I'm trying to see
Yeah.
how big that plate
You
is.
lift the whole plate.
Try to retain it.
Just tell you what.
There we go.
to be picking the edge of it to put it below the.
Yeah. But if it's too much the surface, I mean, those little chips,
All right, as we enter about our last half hour on the bottom here, you are watching live footage from the remotely operated vehicle Sebastian. We're currently attempting to pry some rock up off the bottom about 2.5 kilometers down on the East Pacific Rise. Today's dive was primarily looking for a site to deploy a experiment tomorrow, and that experiment will be kind of near here. We put down a little frame marking where it was earlier. Oh.
You got a little less bar to that, see, I'm not this off.
There is progress being made on that.
Just you have to try it to get a feeling what is really not possible and what might be possible.
That's enough.
Wait. And we're sitting on it.
Can you stand and do the opposite? One on the other side?
Hold on.
Yeah.
Always one of the issues.
I mean, that's what we want to do for a dive, yeah.
I mean, we have the plate right here. We know where it is. We could leave that.
The plate, Tica, whatever.
No, hold on.
You find it now. This side, yeah. Sorry. Asking for the impossible.
Should I finish this one?
Yeah.
There we go. Got that back out. Alright, sounds like we might give it a shot with the port side manip here. Just passing it over. Okay.
Okay, I'm stopped. Just a set.
Oh.
Tell me the angle you want. That's going to go forward. Yeah, I know where you're at. That's the one. Push away. So, you're able to go further out. Yes, better. Yeah,
We'll close up. I'll have this job.
we go.
Alright, having transferred and regripped it, we're back for a moment.
Okay, it's the other side. So basically, you're trying this side, or the other side. So try the back side, because there's a, so this here, there's a little crack there, and there's a crack around the back. So this little piece here might be there.
Trying for a slightly smaller triangular site that we see.
I reckon going in where you went before, just trying the opposite way. Might less up. So again.
Something moved there.
Then he's looking at another option here because these are not
Yeah, it might be a thing where we return to
I
the
have also
site.
the feeling that the top, where we actually have the mesh boxes, are a little bit thinner, but we cannot try next to it. So this, also,
Let's just pop up, have a good look, just coming off this.
we can leave the weight the thing
Yeah,
here, no?
do that,
Okay.
yeah. So,
Thanks
All
for
right.
trying.
So we'll leave that weight in place and might return to this site at another time. Try a little more prying. Got a little more time on the bottom here, but our bottom time is coming to the end.
yeah, that's really substantial.
Yeah, I mean, you were in the crack like this deep, no?
Yeah.
So. When pieces like this in here, for example, when it's a crack, I mean, you can break off, but the boxes, I don't know. You might have to leave the small pieces that we look at carefully.
There you go. Straightened up.
There's a square right there.
But we are yeah, almost out of time, so.
Well, let's just have a look at this square block. Because that looks as though that's not attached to much.
Here you see the figure, this part. So.
Yeah, but see that one in front there? It's got
Yeah, this.
it's
A little one?
Yeah,
A little chunk?
Yeah.
this is a little chunk. Where, yeah.
Yeah, right there, maybe. This gives a nice indication of kind of how thick that crust could be right there, though.
Just gonna try and do the balance again.
Do you want to rock? Do you want to find out how hard it is to break up rock?
We can pick that off, that'll be useful for you.
I haven't been putting on the microscope.
You'd have to break it small over here.
Yeah, if you can break it off and we have no time anymore, then we just can leave it there, no? And I can think,
We can try and figure out how we can chop it here.
yeah, I mean, just try, because at least we know how, if it's possible to lift it, you know?
Yeah.
If you can go
Also, a little piece behind as well, see what we're trying
Yeah.
with this.
the smaller one, but here's, the thickness is basically, if you can
Oh,
the
yeah.
right angle go underneath, then you can pull it out and I don't know.
What's happening here?
You're not in the right angle, but we could take it and drop it and then it will break. This corner here, this is, I think it's the Or you saw the other one, the smaller one, no?
So this part is a bit more approachable. Let's see, I'll give you all a little bit of a top-down view there. Not staring at an elbow.
just crumbles. I got it.
And then we'll take that piece.
I wanted the whole.
Yeah, yeah.
You can, if you can still have time, 10 minutes, you can throw it in the one.
So that's the problem we've run into is once we're actually lifting the rocks, they do like to crumble. Obviously, prying it loose, a little difficult. Moving the slabs, also very difficult.
Yeah.
We will want to.
Yeah, so I'm just gonna stop it here. Okay. My box 2 first.
That box going first. Oh, never mind.
Yeah, open only one and put it, yeah,
What's going on?
great.
Alright. Camera's coming back. Back.
This is Tica, this is primitive.
Lava flow suburbs. Wow. The rock I would be most interested in is the one that is right at the crack. This is the one that broke off now, I think. But if we have no time, then we pick it up.
What?
Just point you
Yeah,
on.
that
I'll see what we get.
Okay.
Put the. Do you want us to put the bungees on before we come up?
We're gonna have to sort that out. It's just,
Alright.
Yeah, little caught in the seal there, but we'll fix that.
Which rock are you interested in?
This actually here,
okay.
this part,
Alright.
or maybe even this part, this here,
Okay.
and this.
The back part?
Hmm.
Okay, and I'll set up here. You can see it again.
Sitzens. So. Ja, das bin ich aber überlegen, weil manchmal ist gar nicht so leicht definieren und was ist ja auseinanderhalten.
Yeah, yeah.
Muss ich mal anschauen. Also manchmal ist die Röhren ein bisschen untypisch. Wenn sie sehr unterschiedlich sind, diese Riegeln, so ist auf jeden Fall was ist, ja.
Das Tier schaut sehr unterschiedlich aus.
Ja. Der am Blumen kennst du sofort, wenn du. Das ist auch alles, ist ja, glaube ich. Wir haben keine richtige Tefni, haben wir gesehen. Where the animal sits on it behind you, but I think this one,
That's one big rock.
this here, so this here, I think they're sitting on it if possible, if this is possible. Would be just very interesting for me to see.
Still a little bit away.
There's a whole bunch of stuff like that.
Yeah, this, but I think it,
There's a whole bunch of different stuff.
yeah. Okay, this is, oh, this is perfect, perfect, perfect. If we get some pieces of this, I would be very happy.
same sample, you want to send sample?
2 rocks in Fava Flow suburbs from crack.
All right, so here we've got a bit of the rock that has some worms on it, and this is some rock that was more in contact with the venting itself. Nice. All right, so we've got some rock samples there. The pilots are gonna work to get that bungee out and maybe secure the boxes as well. And we'll be headed up. So I think once again, if you are watching on Facebook, that'll probably come to an end here. And I think we'll probably run Midwater on YouTube again. I'm going to hand this seat on over to Juliana. And yeah, we'll see you all tomorrow. And we'll see what we find in the midwater.
You want to, when you see it lifting, you want to move it, you know. But this is if it's really big, it's, I don't know. Let's see what I can see with this here.
We're just going to put the bungees on both these bio boxes to make sure everyone's sealed.
And what am I? There was something. Oh no, there was nothing I have to, because for number 1, yeah.
Yeah, and then number 2, we've got one at the front.
Okay.
And then we just keep checking everything's secure.
Yeah, yeah. Okay.
Wait, I'm poaching a little bit lower. Want to grab it first?
Aussteigen, dass man dann nochmal das hinsieht, ob es wirklich eine war oder nicht. Weil das war ja, glaube ich, 2 Meter.
Wir sind schon drüber über die Zeit. Also das muss man merken, aber ich weiß, wo sie ist, weil man, das sind zwischen die Tauchgewichte und wo unser Gewicht liegt.
Ein paar Batemotivlos bärisch und das eine müsste am rosa Rand hinten und der Öster kommt drauf und ich bin mir ziemlich sicher, dass das eine war. Aber man hat es halt nicht.
Die kriegst du da auch nicht raus, die kannst du da anschauen, wenn du willst. Weil wenn die da drin quetscht
Nein, die ist eigentlich, es hat ausgeschaut, wie wenn die drauf liegt, aber die Muscheln halt.
Dann war es vielleicht der Tode, Batemotivlos, das schaut oft so gleich aus,
Ja,
wie man schon so auftäuscht, weil jeder schreibt Batemotivlos, dann schaust du hin, dann ist das einfach die Schalen, wo das obere runtergeht.
Okay, hi everybody, this is Juliana.
Ja, wenn die,
We are doing the final bungee connections for these bio boxes before we head off bottom. The reason we're doing these is to protect any live species as we leave bottom and head towards the surface. The water temperature gets a lot warmer, and they also go through periods of no oxygen. And so we want to limit the amount of water leaking out of the bio boxes so that we have the best possible chance of these samples surviving until the surface.
This is the third one.
I cannot go now, so I have to take this stuff then.
So,
you can bring the firewalk back up as well if you want.
Yeah.
We're almost there. Just almost there.
I got some in the note.
Really?
For the door, for the
Yeah, sure. I will go talk with you around it.
Okay.
Okay.
Monica, are you able to give a sign off for the dive? Doesn't have to be.
Okay, then maybe not today.
Okay,
Because
no
I'm
worries.
really.
Okay. There you go. Yeah, the other one's over there. So yeah, see the hook, so it comes up. Come in a bit. It's coming in. Come in a bit.
Thanks a lot.
No problem. Try that.
Okay. Sorry, guys. Loud noises in the background.
Got it.
Okay.
Okay, that's good.
Nice.
Do you want to put your suction sample hold up there? Yeah, fine. Okay. All right. I'll let you take over. Yeah, it's just pinned, basically. We've got 2 rock samples in the back one, and yeah, we need to. We're on about making it bigger or something. It's like the drawway didn't quite. Yeah.
So,
Oh, yeah.
Bit disappointing, but
do we have that on us, or are we leaving it?
no, it's on this beside the experiments. So we'll leave it there just now. We haven't got the art. We've left that down. They want to leave it for another day, so that's all right. And you got 2 samples.
Okay, we're just doing a quick handover before leaving bottom.
Suction sample.
Okay.
Basically. I think that's it. Yep.
All right.
Thank you to Russ and
Did
Chris.
you want to fly it?
We will now have
Yeah.
Alex flying and Chill co-piloting.
Yeah, tracking that stuff's not easy, like.
So besides the porch change, we'll look at that cable for the internet.
Yes. What's it actually?
Well, we did that about. You saw that? Yeah, that went nuts.
I'll do it tomorrow morning. I was going to change the rubbers out, and I've got a spare set made up, so I'll do that tomorrow morning. Yeah, cable in that.
For your information, if you're constantly impressed by how much Alex is working on dives, we actually have a bunch of Alexes on board. So we have an Alex as a ROV pilot who's currently flying. We also have Alex MMT, who you're here for most of the dive. We also have a fitter Alex on board who fixes a lot of broken stuff on the ship. And then occasionally we'll have an MMC Alex who produces the videos you see. So we have many, many Alexes aboard. Falcor too.
The same cable issue, but that thing is dropped out. Like the controller has dropped out like 4 or 5 times since yesterday.
The only time I've seen lights do that before has been in marginal.
Yeah, I've seen it do it
All the
before.
lights?
Yeah.
It seems like the only times it does it is when we're running cabins.
That could be it too, of course. It could be drawing a bit too much, maybe.
Well, look at it, we have every light on full blast right now.
That's true. We don't have the
Well,
floods
we
on.
know they don't like floods.
Do we turn the haulers on now or wait till we get shower?
Shower. Yeah. We can go ahead and pick up. We can start recovering.
300 meters, okay. Get it on up.
Yeah, it happened twice. So.
Yeah, did it once.
Off bottom. There we go.
Oh, it's not much.
Bridge, Robbie. That's RV
Okay. There it is. Yeah, we do have nicknames for the various Alexes. Or if someone's confused which Alex you're talking about, you'll just say, oh no, ROV Alex or Engineering Alex. Sometimes we just refer to them as their last names too. Okay, we are off bottom. We are now ascending. Thank you guys so much for sticking with us on this dive. It was a good one. If you're on Facebook, we will be ending the stream now because we're reaching Facebook's limit. But if you want to see midwater, you can move over to YouTube and we'll keep streaming there. In general, we're going to go off mic for the ascent so we can do some cruise wrapped ups and talk freely, play music. But if something cool comes on, we'll pop back in. So we're still here. Feel free to ask any questions you have. And enjoy the ascent. Okay, if you guys keep wondering why we keep looking at the arm, it's because if we have our camera on autofocus during the ascent, it will try to focus on every single dot that you see flying through the camera. And so we choose an autofocus, which is generally the arm, and then leave it on manual, and then just position it out. So we'll only be able to focus on whatever the camera is focusing on at the depth of the arm. And it's pretty cool to watch these pilots choose what to pick out and how they fly based on what they find. And so Chill and Alex were just talking about how they have the gains up on the vehicle. That means they have more thrust control while we're going through the water column. And the goal is to kind of outrun the winch, basically. So they'll give what they call a big delta, which is the difference between the winch payout and the vehicle depth. Is that correct? Yeah. And so that's kind of their timeline for how much time they can spend looking at an animal. So, you know, if you see us with a really cool animal and suddenly pull away, it's because we've outrun our delta and we just have to keep going up. There's also a lot of lighting control that they do. So certain lights are better for mid-water than others. And then it's pretty cool to watch. Not only are they just flying towards the animal to get it in sight, but they're also constantly adjusting the lights, camera settings, gain on the vehicle. So once I see an animal, they'll turn down the gain to what they're used to flying. And that'll be easier for them to keep it in center camera. All while these animals are doing their own thing and we're just trying to chase them. Yeah, that squid we saw yesterday was so cool. I think it was a glass squid. I don't think I've ever seen anything stuck on the camera. And it was cool because as it got really, really close to the camera, it got shadowed from the lights and then you can just see all of its dots. That was pretty cool. I think we still have a mark on the camera from where it was sucked on. Hello, it's me again. I have a task for you guys. We're trying to come up with bumper stickers for Sebastian. So if you can come up with some bumper sticker ideas, you would make our day in the control room. We're thinking, currently we have We Break for Science on board. But we can also do, I don't know, maybe we need to do cruise specific bumper stickers.
That's a good idea.
Show me your Zoom. Jill came up with that one. Samples on board. Let me know. Thank you for these. These are awesome. We have a ROV pilot that has a thing for googly eyes, so we just find them everywhere, so googly eyes may appear on Sebastian. Slurps for Science, like that. One cool thing that we do for Sebastian is when we have artists at sea, we'll give them a panel, and oftentimes they will put some of their art on Sebastian, and then we'll coat it in epoxy and send it down, and it'll be on the vehicle for a few years until it gets replaced. Our last one was actually done on the Octopus Odyssey expedition, and it was spectacular. One of our scientists actually drew Falcor, the luck dragon, as if he were in Sebastian and looking out one of the portholes. Really, really cool. I think it's on our Instagram. So you should check that out. But we do incorporate artists into Sebastian like that.
Boobs for science.
Boob for Science. What are you? Science boobs. Nice. We'll zoom for squat lobsters.
We're gonna have to write these down.
Yeah, we're taking notes, don't worry.
That was gonna be super easy back.
Not sure what this is. Maybe a ctenophore? He's just living his life out here. Yeah, ctenophore. This guy is really affected by the vehicle, which is why it's just going in circles from the thrusters. I always think it's really funny to think about what these animals must think suddenly seeing Sebastian in this ecosystem that doesn't have any light. Suddenly we're just here with spotlights. Oh, that's really nice. Pausing for frame grab. They must be like, have the coolest stories to tell. No, I swear. It's like this huge vehicle game.
It sucked up Joe.
Yeah.
It took off with him.
Joe. Okay, no more Delta. Goodbye, buddy. Okay, we are almost done taking our first set of floats off. I'm gonna do a sign off, and then I'll stop the stream when we're out of the water. Side note, we can fish if we're in international waters, and we definitely can't swim, which is a bummer. But again, thank you guys so much for following along with us on that ascent. We will be back at the same time tomorrow. We'll be deploying another box, experiment 3, so we will see you there. Thanks again. Yeah, so that right there is one of the reasons we don't do swim calls. Sharks really like the ship. We saw them on the descent as well. Okay, so there's Falcor 2. If you see that tuft kind of out of the bottom, that's our gondola. And if you look really, really closely towards the aft part of the ship, you can see a pole coming down. And that's how we communicate with the vehicle. That dark area, that's coolers, so that's where we take in seawater to cool our engines. And there's some more mahi. Okay, thanks again. See you guys tomorrow.